Hello, I'm Paul Cox, and this is Slooh, the online community observatory. And well done. If you've made it either this late or this early, you've either stayed up late or you've got up incredibly early for this one. This is the second of our live astronomy shows tonight. You may have seen earlier, we did a Mars show, and that was absolutely fascinating. But now, this is the big one, the total lunar eclipse. Now, Slooh, we operate online robotic observatories, just like the one you're seeing there. And that's our flagship observatory at the world-class observatory site in the Canary Islands. And Slooh members subscribe to the service and they get to control those telescopes. Now, tonight, we're going to tell you about a fantastic promotion that we've got, because if you sign up to Slooh in the next day, you are going to receive this fabulous pair of professional quality binoculars, and we're going to tell you a little bit more about those, not just about them, but actually how to use them. So it's going to be a little bit educational. But throughout this whole show, we are going to be with you for, I think it's 4 hours. Series of guests lined up for you tonight. We have Professor Timothy Ferris. He's a prize-winning author, Pulitzer Prize nominated author. He's going to be speaking to us from his home in Sonoma County. We've got Michael Narlock, who is the new Slooh educator. We've got Duncan Copp, documentary filmmaker and Slooh friend, talking to Bob Berman about the moon landings. That's going to be fascinating. We've got Matt Francis. Matt is providing us this particular live image of the start of the lunar eclipse. This is coming from Matt's Prescoll Observatory in Arizona. And we're going to be talking to Matt a little bit later about the aims of his observatory. And it's all about education and outreach. So it's absolutely along the lines of Slooh's main outreach program. And we've got Angelique Bermain. She was going to do another feed for us from New York, but that's clouded out. We've got another feed as well, which is clouded out, but the weather's fine in Arizona, so worry not. If you're under the clouds, we're not. We're going to be showing you these live images all through the eclipse. We've got Jeff Fox. He's going to be a new presenter and producer for Slooh. And last but by no means least, I welcome Bob Berman. He is Slooh's professional astronomer and astronomy author. It's always a pleasure to hear Bob's expertise on these subjects. Hello, Bob. Can you hear me?
I sure can, Paul. Very exciting. We're here in Arizona. I'm sitting here next to Observatory Director Matt Francis and looking through the giant dome slot at the moon as the penumbral part of the eclipse is progressing. We're getting ready for the beginning of the partial phase.
What's the weather like there, Bob?
It's perfect. It could not be better. There's not a cloud in the sky. The weather is crisp. The humidity is almost in the negative numbers. I'd say the humidity is minus 20%. That's a joke, of course. That's impossible, but it's as dry as you can imagine.
Well, that sounds pretty hopeful for us. So we are going to see a full 4 hours of this eclipse as it unfolds. We've got a couple of other feeds as well, actually. We've got one fascinating one from our observatory partners in the Canary Islands. Now, Bob, I'm not sure if you've seen this image yet, but our producer's going to pull this up. This is a special telescope that our partners at the site have set up. It's actually on Pico del Teide. This is the actual volcano that forms the whole of the Canary Islands. So we're about 8,000 feet up in the air. And that very, very bright object we see there is the moon. And of course, in the Canary Islands, it's nearly sunset. So the moon is just about to set. But what we're hoping to see in this view is the shadow cast by Mount Teide, which is this real peaked volcano. And that's going to be cast down as the sun rises, and that's going to cast this shadow down to the moon as it sets. So we're going to keep an eye on that one as well. Angelique Bermain, she's there in Woodstock. What's the weather report from New York, Angelique?
Oh, it's dismal. It's dismal. You know, we had high hopes for a moment. It cleared up, but as of late, it's completely overcast, multiple layers of thick clouds. For a moment, about an hour and a half ago, we had clear skies. The skies opened up. We had Mars and this bright, gorgeous, crisp moon. And for a second, we thought we might get it, but unfortunately, we are back under the clouds.
Well, I know to my cost that all of the preparation is exactly the same before one of these shows, whether or not you're cloudy on the day or not. So huge thanks to you for all of the preparation work that you've done.
Of course.
All we can say is you're going to be ready the next time. So
exactly. And thank goodness we have Matt out in Arizona for this
absolutely.
beautiful
And having Bob there is even more special, to have Bob at the observatory where we're getting these live feeds from. So thank you very much, Angelique. I'm sorry you're clouded out, but like so many of us, I'm in the UK. The sun's actually risen here. We can't see this lunar eclipse anyway. So join the rest of us. Look at these fantastic live images we're going to be getting.
I will be here.
Now, Bob, we were talking earlier. This is a kind of pre-show. We've actually started the show a little bit earlier because we knew that there were thousands of people waiting for us. And we thought we'd have a kind of little bit of an informal chat before the show kind of restarts properly on the hour when we've got our first guest coming in. But right now, as this lunar eclipse is starting, can you tell us what people are going to see? What is it that we're going to see? Whether or not people are in the United States, Canada, or South America, and they're out in their backyards and they're listening to us but looking with their own eyes, or if they're like the rest of us under the clouds and can't see it. What are we going to see?
Well, very simply, the moon is going to go into Earth's shadow. And in ancient Greek times, they figured out that the Earth has to be a sphere, a ball, even though, you know, we've been taught Columbus believed the Earth was round and everybody thought the Earth was flat. Well, then as now, there are going to be some people who think the Earth was flat, but the ancient Greek says no, only a ball always casts a round shadow. And for those who care to look at it, those rather rare times when the moon ventures into Earth's shadow, you can see for yourself that it's going into a curved edge, and that's going to be beginning the black part of the shadow, the emerald part of the shadow, is going to start just 10 minutes from now. And already, those who have clear skies or who are watching us right now as the giant telescope here in Arizona. I'm out here with Matt Francis, the director of the Prescoll Observatory. We're looking through the slit in the motorized dome that's turning, and there's the moon, and there's Mars above it, and there's the bright star Spica just off to its side. And already one side of the moon is looking a little dark because the penumbral shadow is starting to show up. So during the next hour, starting at 2 minutes to the hour, we're going to see the black part of Earth's shadow starting to cover the moon. That'll last a little more than an hour, and then comes the weird, strange, total part.
Now, Bob, you mentioned just then Mars. Now, we did a fantastic show earlier. If you've missed it, you can always see the recorded version. We had Rob Manning from JPL, the Jet Propulsion Laboratory, and we were talking about Mars being its closest to Earth in 6 years tonight. If people are actually watching the lunar eclipse outside, they can also very easily see Mars. So where do they need to look? If they're looking at the moon tonight in their own backyard, where is Mars in relation to the moon?
Well, currently, in most of the United States and Canada, Mars is just above and slightly to the right of the moon. As the night goes on, Mars will increasingly be to the right as the moon moves across the sky, and you can't miss it because it's a very bright and orange star. And the moon, in fact, is going to turn that color too. I've noticed that the media, that many in the media are going to refer to this and have already referred to this as the blood moon. But the moon will not turn blood red. It'll turn a coppery red, and well, we'll see it for ourselves.
Yeah, that seems to be quite a common misconception. I mean, but we can actually tell quite a lot by the type of color that the moon turns, can't we, during an eclipse?
Oh, yes, absolutely. Because what happens if you were stationed on the moon during the next couple of hours and you look back toward the sun, you'd see the Earth being larger than the sun appears, 4 times larger than the sun, looking perfectly inky black, a cameo of an Earth because you're looking at the night side of the Earth, slowly covering up the sun. And when it's completely covered, the sun will be behind the Earth, but surrounding the black Earth will be a ring of fire. All of the world's sunrises and sunsets will be combined into a single ring. That will be the only light hitting the lunar surface then. The very steeply refracted reddened light from all of the world's sunrises and sunsets hitting the moon. And now we're not there on the moon looking at Earth, we're on Earth looking at the moon. So we're going to see the result of the moon going into Earth's red shadow. You and I cast a black shadow when we walk down the street, but our planet casts a red shadow, and that's what we're going to see for ourselves.
And I think what we've seen in the past as well is, depending on the condition of Earth's atmosphere, maybe
very much so, Paul. You're quite right. That depending on the limb or the edge of the Earth, if we have an unusual
something like this.
For example, when Pinatubo erupted in the Philippines in the early 1980s, we had an almost totally black eclipse. The moon didn't turn red, it turned black and just about disappeared. Or you can have an extremely light eclipse where the moon barely turns red. It turns yellow, it turns tan, it turns beige, it turns black, it turns brown, it turns red, it turns orange. The sky's the limit, and this is one of those only cases where we look at another celestial body, we look at the moon, and we get an environmental report card about ourselves. We see the conditions on Earth when we look towards the moon. And the partial phase is all set to begin.
And one of the wonderful things about a lunar eclipse is we never quite know what color it's going to be until we start seeing it in that umbral phase. Now, we're going to use a whole load of terms tonight, but stick with us throughout the 4 hours because we will be explaining every single term that we use. We're going to go to various guests throughout the evening, and the next time we get Bob back in, we're going to go through in quite a lot of detail, I hope, exactly each phase of this lunar eclipse, and we'll be following it with live images throughout the night. Now, don't forget, we are running a special promotion at Slooh. Slooh operates online robotic observatories. Anybody can join up. Anybody can point the telescopes to whatever they like. But tonight, if you join up in the next day, you are going to get a free pair of binoculars. Now, we are going to tell you a lot more about these binoculars a little bit later on because they are really quite special. If anybody wants to know, now they're actually called 12 by 70. These are large binoculars, and we are going to tell you exactly how to use them, what you can do with them and stuff like that a little bit later on. So you get the best of both worlds. You get to command and control Slooh's telescopes, including the half-meter telescope in the Canary Islands. But also, you get this pair of binoculars to see the planets, to see the moon, to see globular clusters and a few other items that you can see in the night sky. But Bob's going to tell us all about that a little bit later as well. So don't forget, that's what we've got. Now, let me tell you who we have got coming up on our show, which is really going to kind of restart in 5 minutes. Don't forget, we kind of started a little bit early because we knew we knew a lot of you were chomping at the bit to come in. We have got, first of all, we've got Professor Timothy Ferris. Now, he's a prize-winning author. He even was nominated for a Pulitzer Prize, I believe. He works at the University of California, Berkeley, and he's got some fascinating stories. But he's going to tell us. I think he's going to be imaging the lunar eclipse later tonight. We've also got Duncan Copp. Now, Bob did a fantastic interview with him, and you've got to read that. Now, Duncan Copp is a documentary filmmaker and sleuth friend. If you've seen a documentary on the moon on TV, chances are Duncan had something to do with it. His films are absolutely wonderful. So great interview there, talking about the moon landings, which is a passion of both Bob and of Duncan. We've also got Michael Narlock coming on. Now, Michael is our new Slooh educator, and he's also going to introduce actually this new program that we've got called Slooh Classroom, and he's the head of astronomy at the Cranbrook Institute of Science, but he's going to introduce this program, and then I'm going to hand over to him for 15 or 20 minutes, and he's actually going to take a first classroom. So I'm really looking forward to that, because I always learn something new when I listen to Michael. So that's going to be terrific to hear about that new program. We are hopefully going to be talking to Matt Francis, who Bob Berman is with. So Matt Francis is the director of the Prescoll Observatory in Arizona. That's where this lovely, lovely live image is coming from. And we can already see, we'll get Bob on it in a minute, we're already seeing this chunk of the moon taken out. The eclipse is fully underway. We've also got Jeff Fox coming on. He's going to be a new presenter, a new host and producer for Slooh. So we're really looking forward to introducing him nearer the end of our 4-hour coverage, would you believe? But back to Bob. Bob, conditions still looking great. Look at this fantastic image coming from the observatory that you're currently in.
Yes, exactly. And people are surprised to see that the edge of the moon now, it looks like it's the umbral or dark eclipse is beginning. We actually have a few seconds more. And the reason it looks dark on the left side is that it's not an abrupt transition. We're looking at a place on the moon where 98% of the sunlight is blocked, and then as you look further to the left, 99 and 99.5 and 99.9. So it's a gradation. You get to the part of the moon where no sunlight is hitting it at all. And that's what's starting now in a matter of seconds. And I should mention that for at least the first half hour, it will look like a black shadow is enveloping the moon. And the fact that you and I both said that the Earth's shadow usually shows a coppery red color, people will think, well, we were mistaken, we're wrong. But thanks to the eye, and in this case the camera and all this marvelous equipment, adjusting to the brightness of the sunlit part, the dark part will look black at first, and only as the eclipse is near the end of the partial phase, and then certainly when it's fully eclipsed, then we'll see the true color.
Yeah, and Matt's having to do an awful lot of work there. I know he's got a video feed that we're going to show later as well, but these images are absolutely stunning. So thank you, Matt. I know he's going to be working furiously in the background. Bob, just tell people before we move on to the next segment of the show, I'm going to reintroduce the whole show, introduce our next guest, Professor Timothy Ferris. Tell viewers who are watching this in their own backyard how best they can watch a 4-hour eclipse. I mean, I always get a kind of sunbed chair and basically just sit back, relax, get a blanket over me, and usually a hot thermos next to me. What else would you recommend for people?
Well, definitely. And now the partial phase has begun. The shadow of Earth has now started. So people who are in their backyards or looking out their windows, either using binoculars or the naked eye, that's the best. You really don't want a telescope for this unless you've got the exact best kind of equipment. Unfortunately, there's a big chunk of the United States that's under clouds right now, and those who are suffering from clouds, just stick with us here because we're bringing it to you live. So the eclipse is now underway. We are seeing the black shadow of the Earth. It's very interesting that the shadow's radius, you can see the curve curvature of it is not the same as the moon's radius. And that's because Earth starts out being 4 times the size of the moon, and our shadow tapers like a chopstick to get smaller and smaller. And even at the moon's distance of 250,000 miles, the shadow is still twice as large as the moon. So we're seeing different radii or curvatures of shadows and curvings. You see the edge of the moon has one type of curvature, a greater curvature, and the shadow that it's going into has a different curvature. So it's quite a kind of wonderland of different geometries here.
Thank you, Bob. We will be coming back to Bob Berman after our next guest. We're kind of restarting the show. We started a little bit earlier. We started 20 minutes early because we knew a lot of people were wanting a bit of an explanation beforehand. But I'm going to reintroduce our show now. Hello, I'm Paul Cox. This is Slooh, the Community Observatory. We operate online robotic observatories. Our flagship observatory is in the Canary Islands, and that is perfectly timed for people in North and South America because it means basically you can control the telescopes from the comfort of your own home, but not have to stay up all night, not like everybody's done tonight. Everybody tonight has either got up incredibly early or stayed up incredibly late to watch this fabulous lunar eclipse, and this is a live image that we're seeing at the moment on our screens. Now, our flagship observatory is at this world-class observatory site in the Canary Islands, and our partners there have organized a fantastic image which is going to be showing the moon setting, and where our observatory is, there's a large volcano, and that volcano is going to cast a shadow that points directly down to the moon. So we're going to keep an eye on that and share that into our broadcast during the show. Now, we are celebrating our 10th year of operation this year, and we've got some big plans to market. Not least, we are running a special promotion tonight. And if you fancy controlling robotic telescopes in a worldwide community of other amateur astronomers who just love this stuff, right, we will also give you a pair of free binoculars. These are large binoculars, 12 by 70s. We're going to tell you all about them a little bit later when Bob Berman comes back on. But for now, I would like to welcome our wonderful guest. Thank you very much for coming on, Professor Timothy Ferris. Now, Timothy Ferris is a prize-winning author, and one of his books, I believe, was Pulitzer Prize nominated. Timothy, can you hear us?
I can hear you, Paul.
Thank you so much for joining us. Now, you are in Sonoma County. For those of us who are not in the United States, whereabouts is that?
I'm about 60 miles north of San Francisco at Rocky Hill Observatory, which was built here on Sonoma Mountain some 20 years ago.
And what's the weather like for you? Are you going to get to see the eclipse live in your own backyard observatory, or are you watching the images with the rest of us?
Now I'm looking at the actual moon. It's a bit soupy here, and there's some high clouds going parallel across the sky like great white brush strokes. Mm. But and there's also quite a large halo. Well, it's always the same size halo, ice crystal halo around the moon. But there's a pretty good view even through all of that, and we can see the eclipse starting to take a bite out of the forward or eastern side of the lunar disk.
I sometimes feel you'll see either the moon or the sun behind it. That actually it adds a little bit of depth sometimes to it. Is that what you've got, or is it a bit soupier than that?
No, it's not bad at all, and we had an experience of that at moonrise here 3 hours ago at 8 o'clock Pacific time, when the moon rose in the clouds, looking rather coppery and odd, even though it was before the eclipse had really begun. So I find that the weather can sometimes add a bit to stargazing.
So there's going to be a lot of people tonight who are weathered out in the United States. We've lost 2 of the image feeds that we were hoping to have, and I believe a lot of the country is covered in clouds. So you're one of the few and far between who have got some clear skies. We've got these fabulous skies. I don't know if you can see our images at the moment, can you? This is coming from the Prescoll Observatory in Arizona. And is that exactly what you're seeing?
At the moment, I'm up in the open on the observatory deck itself, and the monitor here is displaying the results of a time-lapse sequence of photos that I'm taking through a 750 millimeter lens. And in some ways, the photos show the eclipse even more clearly than the naked eye view, because that is, of course, a bit of a telescope on there. So no, I'm unable to see your feed on these monitors, but I do have multiple views of the eclipse, and I can see it just over the trees here in the southeast, now getting to be kind of a pronounced bite out of the moon. And
which is exactly what we're seeing. We are seeing this very obvious arc of just blackness, really, a chunk being taken out of the moon. Now, you must have viewed quite a few lunar eclipses and solar eclipses, but this, I don't think you've had in the United States, have you, a lunar eclipse for quite a time?
It's been a while. I think the first time I photographed one of these was on the age of 16, which is a very long time ago, from Florida. Change in color of the moon as the eclipse progresses. You never quite know what it's going to look like. It's a result of the particulate matter in the Earth's atmosphere. And at this point, I should say, looking at the moon now, that one can see particularly well the sort of ragged edge that the Earth's atmosphere causes in its shadow. It's not a knife edge such as you see in the solar eclipse when the moon passes in front of the sun. You could, if you were dropped here from somewhere far across the galaxy, you could quickly conclude that you were seeing the edge of a planet with an atmosphere.
So this is not the only eclipse that I think the United States and North America is going to have, is it, this year? Aren't there a number? I think there are 4 eclipses
yeah, we're in one of those
year.
cycles where there'll be several, so if you're weathered out this time, keep an eye out for the next one.
Now, one of the questions that we've had use that hashtag. Our producer will be monitoring that all night long for the 4 hours, and they'll feed through questions. And one of those questions is why doesn't a lunar eclipse occur every month at full moon?
Well, the eclipse occurs when the moon in its orbit happens through the Earth's shadow, and if the plane of the moon's orbit were lined up properly, you would have an eclipse every month, every lunar month. But because the orbit is inclined, like a pair of dish plates, the top one not set in quite square on the bottom one, you get only 2 points in the orbit where they intersect, what are called the nodes. And to have an eclipse, that node has to lie right where the Earth's shadow is. So they're rather rarer, but because they are cyclical, it's been possible to predict them for a long time. And you may recall that Christopher Columbus fooled some Native Americans into
That's right.
coming up with provisions for his starving crew by warning them that he would cause the moon to be eaten up that night, because his tables showed that there would be a lunar eclipse, and it did the job. This bit of deception worked, and the crew survived. I'm here.
Yes, Bob Berman here. Yes.
This is Slooh, the online observatory. We are broadcasting tonight live for the full 4 hours, the total lunar eclipse, which is visible over North and South America tonight. Now, if you have made this show, it means that you've stayed up incredibly late or got up incredibly early. I'm broadcasting from England, and it's 7:10 in the morning here. We have a feed coming in from the Canary Islands, which is going to be absolutely fabulous. This is from the Slooh Robotic Observatory in the Canary Islands. This is where our telescopes are based, and our producer is going to pull this in. And this is a telescope specifically set up right on top of this volcano, and you can see this ice and snow in the image. It'll come up in a second. And we are going to be watching the moon set there as the eclipse takes place, but we're going to see this fabulous shadow, this triangular shadow cast by the volcano off towards the horizon just as the moon is setting. And there you can see this image. So what we're seeing here, the very bright object is the moon. You can see the clouds below because Slooh's observatory is at this world-class observatory site. It's 8,000 feet at altitude up on top of this volcano where the air is incredibly still. We're usually above the clouds, so the astronomical seeing is absolutely perfect. Now, you can control those telescopes, including the Slooh half-meter telescope. That's a telescope with a mirror 20 inches in diameter. Now, that gives us some fabulous images of nebulae and galaxies, all in full color, because Slooh does all that hard work for you. We've actually got a patent for that we might tell you about a bit later. But anyway, you can, if you join up within the next day, we are going to give you a free pair of binoculars. And I'll tell you, these are not a cheap pair of binoculars because it's pointless buying cheap binoculars. This is a professional pair of 12 by 70 binoculars. They're really pretty big. And we're going to tell you a lot more about those a little bit later on in the show. But back to our esteemed guest, Professor Timothy Ferris. Professor Ferris, we were looking at Mars earlier on. We did another live show a little bit earlier on. And with Rob Manning, from the Jet Propulsion Laboratory, we were talking about the prospect of finding life elsewhere in our solar system. Now, I believe you've written about life beyond Earth, haven't you? So what's your kind of current thoughts on that subject at the moment?
Well, I've always felt that it's likely that that life is commonplace throughout the universe, but of course that's just an opinion. The question is, what sort of evidence can one find? And we're a lot closer to having the tools necessary to look for life in a variety of extraterrestrial environments than we were even a decade or two ago. The reason that I say that I'm inclined to think that there's lots of life out there is simply that if you look at the history of the Earth, life got started here pretty early on, and the Earth doesn't show any obvious signs of being highly unusual, and there was no sort of event that seems unusual in the history of the world that might have caused this. And when you look at the way life functions, it operates the same way everything else in the universe functions. So it seems to be a natural process that arises, I would think, anywhere it can. But again, when we start to get a telescope in space that can obtain spectra from extrasolar planets, we'll have some evidence to see whether these optimistic statements have any validity or not.
They are optimistic, and I know a lot of us are kind of willing us to make these discoveries. Now, we have had another question, actually, which is kind of related to one of the questions I wanted to ask you before we let you go, because I know you're wanting to photograph the total phases of this lunar eclipse. And I was doing a little bit of revision on our guest tonight, and I saw that you were a one-time editor of Rolling Stone magazine. Now, tell me how an editor of Rolling Stone magazine lands up producing the golden record that's now traveling beyond our solar system on the Voyager spacecraft. How on earth did you get involved with that? And could you explain to our viewers exactly what this golden record is?
Sure. There are two Voyager spacecraft, the first of which just officially exited the solar system quite recently, just a matter of months ago. Well, I guess if you go back to the announcement a little over a year ago, they will the velocity they achieved when they went past the planet Jupiter and got a momentum boost from the giant planet flings them out of the solar system, and they'll wander among the stars forever. When this mission was being planned, Carl Sagan and his colleague Frank Drake argued for putting a record on the spacecraft, because it turns out that grooves in a metal record last a very long time, 1 billion to 2 billion years or more in space. So that if any civilization should ever come across a spacecraft long from now, there would be a kind of audio and visual scrapbook of who we were as a planet back in 1977 when the spacecraft were launched. I knew Carl quite well, and when they were in the early stages of planning, he asked if I wanted to be involved in the project, and that's how I came to produce this recording, which has 90 minutes of music on it and a bunch of photographs and natural sounds of Earth. It was a good
There was
project.
some resistance, wasn't there, at the time? That people worried that, we were basically giving people the map to find Earth to whoever may find this thing?
There is in fact a pulsar map on the jacket, the aluminum case.
We are actually looking at an image of it at the moment, and it's the series of lines down in the left-hand corner for viewers.
Yeah, it does allow you to pinpoint Earth, and there was a plaque on a prior space probe that also left the solar system, although it's moving more slowly, so it's actually now behind Voyager 1. And those maps do make it possible to locate us. When Carl was asked about this, he used to point out that our radio broadcasts have made the planet conspicuous for about a century now. They travel out through space much faster. So I suppose you could say the same thing of a note in a bottle. But I think even if there are a great many civilizations of intelligent life in the Milky Way galaxy, it would still be many, many eons before the odds would favor someone coming up with a spacecraft. Whether we'll even still exist then, or who or what we might be, is a difficult question.
Now, while we go back to some live images of the moon, you mentioned there that the Voyager spacecraft had left the solar system. Now, that was quite a monumental point in time, wasn't it? This was last year or the year before?
Well, the announcement was, I guess, late last year, and the announcement was that the data indicated that the spacecraft had, in fact, left the solar system the previous year. For these purposes, the boundary of the solar system was defined by the point at which the spacecraft passed through the rather thin bubble that surrounds the sun. It's created by particles streaming out from the sun. Then they eventually slow down and stall against the thin interstellar medium. And when you poke through that bubble, according to the NASA standards, you have left the solar system.
And that's what happened last year. So it must be an amazing feeling that something you had a hand in producing is the first object to exit our particular neighborhood of our galaxy.
It is quite remarkable. I mean, once you get out there, the velocity of the spacecraft really counts for next to nothing. It's the spacecraft just drifts like as the sun does in its orbit around the center of the galaxy, and other stars do the same. So that people ask sometimes, well, will it ever pass near another star? And then it will. It'll pass near various stars, but only in the sense that if you're in a lifeboat and you see an ocean liner off on the horizon, it's you're passing near it or it's passing near you, but everything's in motion out there. I think it speaks well for people that we put a little note like this on a spacecraft. It says that there's more to us than the science and technology that created the spacecraft itself.
How can people find out, Professor Ferris, what's on the record? Is that available somewhere so they can hear what was chosen?
Yes, there are various websites. If you look under Golden Record or Voyager Record, that lists the contents, and there's also a book called Murmurs of Earth that the folks who worked on the project put together to have an accurate record of what the contents are.
Now, we are going to come back to Professor Ferris for a live eyewitness report on what he can see from California at the moment. But we're going to nip back to our special image from the Canary Islands at the moment. Now, this is a fascinating image. This is from the Canary Islands. The Canary Islands are a volcanic chain of islands in exactly the same way that Hawaii is. They're very tall. They're in the middle of the Atlantic Ocean. Well, not in the middle of the Atlantic Ocean, but they're set in the Atlantic Ocean, which means that you have this very stable airflow that comes over these very, very high volcanoes. And there's no better place on Earth to put telescopes, because it means you're above all of the turbulent air below, you're above the clouds most of the time. And this image that we're seeing now is being made available to us by our partners at the site. It's the Institute of Astrophysics in the Canary Islands. Now, this is well above the actual observatory. This is actually on what's called Pico del Teide, and this is just one cinder cone. And what we're seeing here, I know the image is a little bit at an angle. That's because I kind of imagine behind all of this there's a photographer clinging on for dear life on the side of the volcano. But what we're seeing there is the Pico del Teide is the kind of hill that we see running up on the right. We can see it's high altitude, it's covered in ice. If we look further down to the left, that's actually the caldera. The dark area that you see there is the caldera of the volcano, the main volcano. And we're seeing a little bit of shade and a little bit of light coming in there. Then we can see behind it the clouds and the horizon. We can even see the curvature of the Earth because the observatory is so high up. And don't forget, this is where the Slooh telescopes are, and anybody can control the Slooh telescopes. Just join Slooh, and you get to point those telescopes wherever you like to get full color images. We're going to show you some later. But there we can see the moon. Now, the moon is setting currently in the Canary Islands. It's just off the west coast of Africa. And what we're going to be keeping an eye on is the volcano, this pointed cone volcano, is going to be casting a shadow. As the sun rises in the east, it's going to cast its shadow down to the west where the moon is setting. That's going to be an absolutely spectacular image that we are going to keep an eye on, and we'll make sure that we show you that. Professor Ferris, how are conditions there? Are the clouds getting any worse, any better? And what exactly
slightly better, I would say, Paul. The almost half of the lunar disk is now covered, certainly more than a third. I just noticed through binoculars that the bright star Spica, Alpha Virgo, which is it's quite close to the moon, just about 2 diameters of the moon to the south, which was not previously visible because the moon was so bright, particularly in this thin gruel of clouds. But that star is now visible. The reason, of course, is that the moon, as the eclipse proceeds, becomes dimmer and dimmer. And so across the sky, stars that were not visible in the bright light of the full moon are now coming out.
And what we're seeing now in our live images is exactly what you're seeing from your own backyard. We are seeing, I don't know, I guess about a third of the moon has gone just jet black. Now, I'd like to invite in Mr. Bob Berman, Slooh's astronomer. Bob, have you got any questions for Professor Ferris?
Questions? No, I would just say that I'm a longtime admirer, and Timothy Ferris is certainly one of the great astronomy writers of the last century.
Okay.
Thank you, Bob.
Mutual Admiration Society. Let's start it here. Professor Ferris, thank you very much for joining us tonight. I know that you're running off because you want to capture the total phases of the eclipse tonight. So thank you very much for joining us. And we must have you back at Slooh to talk about some of your other work. So thank you very much for joining us tonight.
Thank you. It's been a pleasure. Enjoy the eclipse.
Well, enjoy the rest of it yourself as well. I hope the clouds stay away.
Thank you. Bye-bye.
Bye-bye. This is Slooh, the Community Observatory. I am Paul Cox. We are showing you live images for the full 4 hours of this total lunar eclipse. Our live images tonight are coming from the Prescoll Observatory in Arizona. And the director there, Matt Francis, is a great Slooh friend. And we'll talk to Matt a little bit later because it's fascinating to hear the goals of his private observatory there, which is all about education and outreach opportunities. And, you know, this is what we love doing at Slooh as well. It's Slooh members, though, make all of that possible. Slooh members joining up to control the telescopes make it possible for us to put on these free live events for everybody to view. Now, Bob, what can you see there? We can we're about to see a picture of you and Matt in the observatory. How are things going?
Yes. Well, we're here. That's right. Matt is on the right. I'm on the left.
I'd love to view it. Looks like you guys are in the command capsule or something like that.
Oh, yes.
Oh, yes, we are. And in fact, perhaps Matt can even tilt the webcam to show you some of the telescope
that is tracking the moon right now. Can you do that, Matt?
Can you do that, Matt?
That's being doing this right now. I think you'll be able to see some magnificent equipment that is being trained on the Eclipse moon. And as for the Eclipse,
which telescope are we using tonight, Bob?
And I will put him on to actually give you the technical details in just a moment. I do want to point out that at this stage of the eclipse, still, it looks like the shadow of the Earth is still black, but there is a slight little hint of the reddishness that is to come. And as the eclipse progresses from this point on, we're going to increasingly see a reddish cast. Indeed, the star Spica, bright star in Virgo, is on the moon's right, and Mars looking brilliant in some distance to the upper side of the moon. Now, people who are watching it live or who are with us, one thing stands out. This is really very interesting. At this stage of the eclipse, you might think, if you didn't know better, and you did not know an eclipse was underway, you might think that you were looking at a phase of the moon. We were looking at almost a half moon. In other words, a first quarter moon, which is lit up on the right, just the way this looks. It looks somewhat like that phase. And for the next 10 or 15 minutes, the shape of the moon will somewhat resemble a normal lunar phase. But starting about 25 minutes from now, the moon will take on an absolutely bizarre appearance. This is before totality. Totality is the main event. That's still to come. But before totality, the moon will look so strange because it will appear unlike any other way it ever looks. In other words, the lighting that hits the moon will be very unlike that of a normal phase. So the familiar moon is about to disappear.
Bob, just while we've got you there, we're talking about the timings and the phases that are going to occur. Can you give both viewers who are watching our live feeds here and people who are in their own backyards, can you give them the timing of when they're going to see each part?
Yes, absolutely. Depending upon the time zone they're in. Right now, it's about 27 minutes after the hour. Now, the partial phase is going to continue for another 40 minutes or so. And then 6 minutes after the next hour is when the total phase will begin. But I think the weirdest, strangest, most valuable time to be observing this event will be in the 15 minutes preceding that. So starting 25 minutes from now, the moon will change from what it now appears to be. You could almost say, hey, look, it looks like a normal first quarter moon, to an absolutely bizarre moon. One of the differences is that an amateur using a small telescope or a pair of binoculars, if the moon really were near the first quarter phase and you were to look at it, you'd see a lot of craters and mountains because the moon would be lit up on the right. That's the way it looks if you look in the sky now or use the Slooh images. But the moon is actually being lit up from directly straight down on it, except half of the light is being blocked. So instead of the light coming from the right, the way it normally would when the moon has this appearance, the light is still shining straight down on the moon. So appearances can be deceiving. This is a very strange event that we see unfolding.
So we've got a message here. Don't forget, you can message us for the next few hours. We've got another, I think it's 3.5 hours to go here. We're going to be covering the full total eclipse. We're going to be with you for the whole duration. And we've got a question here, Bob. By the way, just use the hashtag Slooh, S-L-O-O-H. We've got a question here from Lunatic Savage, and it is, how long till it goes fully red? So I think we're talking about an hour, just over an hour, aren't we, Bob?
No, we've only got about 36 or 37 minutes until it turns fully red.
Okay, and how long is it going to stay in that phase?
Oh, and then it will remain that way for almost an hour and a quarter.
Right, so we've got plenty of time to see that.
And do you know why, Paul? I mean, I know you know why, but listeners may not know this. The reason that the eclipse lasts for an hour in totality, and the reason it takes an hour for the moon to fully go into our shadow, is the astonishing fact that the moon is the only celestial body in the entire universe that we know of that moves its own width in 1 hour. The moon is 2,160 miles across in diameter, and its average orbital speed is a little over 2,200 miles an hour. Those numbers are almost the same. Its diameter in miles and its speed in miles per hour are two matching numbers. And because of that, it takes 1 hour. No other celestial body does that. 1 hour to go into Earth's shadow, and then it remains in the shadow for about an hour.
Bob, we've got another question coming in here, and it's a great one. This is the kind of comment that we love to see coming in. This is from Matt Beatty, and he's saying, Slooh, it's 12:20 here, and I've kept my boys up to see the eclipse. Hopefully, this will be the inspiration for them to get more interested in astronomy and make sure that they stay up for a little bit longer yet, because we've got Michael Narlock, the new Slooh educator, who's going to be introducing the Slooh classroom program. So please, Matt, keep them up a little bit longer. But his question, Bob, is the boys want to know if the moon has tectonic plates like Earth.
No, the moon does not. Ever since Alfred Wegener announced his belief that Earth has tectonic plates, that was in 1919, and it wasn't until the late 1950s that it was widely finally accepted. And the reason was that, okay, it looks like the continents of Earth are like a jigsaw puzzle that would fit into each other, but there was no possible method of plates moving until we got the bright idea, hey, you know what's under the crust of Earth? Liquid, what we used to call lava, now we call it magma. And if that's liquid, well, maybe the continents could float. Well, fine, they float, but why should they go sideways? You know, Asia is not a small item. It's not a lightweight item. Ever try pushing a stalled car? You know, this is not pond scum that we're talking about. We're talking about a major item, so why would it ever drift sideways? And now we know that fissures open up on especially the mid-Atlantic plate. The mid-Atlantic fissure pushes the continents apart. The moon does not have that. There is no liquid under its surface. There's no floating crust. The moon is solid all the way to the center. In fact, that's why it shakes like a bell. It rings like a gong when a giant meteor hits it. It shakes for 3 hours and rings like a bell. And it wouldn't do that if it had liquid below the surface the way Earth does. So, long-winded answer to a short and good question, which is, does the moon have plates like Earth? No, it does not.
And keep those boys up, because we have got some fantastic coverage for you. Loads more information, special guests coming in by the truckload. Now, Bob, we were going to show your discussion with Duncan Copp, the filmmaker, at around this time, but I think we should probably stay on air to talk more about the mechanics of the eclipse, explain to people exactly what's going on, so that we can maybe get to that point where you said is one of the most important stages of the eclipse. What do you think?
Yes, I think that's an excellent idea. And if you'd like me to begin, I shall. It just starts off with a shadow. We all cast a shadow. Earth's shadow goes for 1 million miles in space, 1 million mile long shadow, growing smaller and smaller, tapering like a chopstick as it does so. Now, the moon is 1/4 of a million miles away, so that means the moon is well within our shadow's ability to touch it. Our shadow can hit no other celestial object. Only the moon can venture into Earth's shadow of all the natural objects. Well, of course, there is the occasional near-Earth asteroid, near-Earth object that can do it, but of the normal celestial objects, it's only the moon. And yet, at the moon's distance, the Earth's shadow is shrunken. It's not 8,000 miles wide, but closer to 5,000 miles wide. So as we look at the moon right now, we're seeing the curved edge, the bright edge of the moon. That obviously has a very strong radius of curvature. But now look at the curvature of Earth, and you'll see the curvature of Earth is closer to being a straight line. It's not a straight line. It's got a little bit of a curve to it, but much less of a curve than the moon has. So right there and then is proof that A, Earth is round, because only a ball always throws a round shadow. If Earth were a dish or a disk, a flat plate, we would throw a round shadow only when we were aligned perpendicularly to the sun, which would be rare. Other times we might throw a straight line shadow. Only a ball always throws a round shadow. So we know that we're a sphere. And unfortunately for you Flat Earth Society members who may be watching the eclipse, you're going to have to resign your membership, because there is the proof. The second thing we're looking at is proof that Earth is bigger than the moon, because we can see from the shadow that the moon is going into that Earth has got to be a bigger ball than the moon. And the third thing we can actually infer from this, and this is without any particular knowledge, is approximately the motion of the moon. If the moon takes a month to circle around us, it's actually 27.32166 days, about a month. Let's round it to 4 weeks. And it takes an hour to go into the shadow. If you do the math, you can figure out how fast the moon is moving. And it's about 2,200 miles an hour. That's pretty fast. I mean, it's nothing like 60,000 miles an hour, 66,600, but that's the motion. So just by doing the observations we're doing right now, we can learn all these things about the Earth-Moon system.
Your encyclopedic knowledge always astounds me, Bob. It
Thank
really
you,
does.
Paul.
So I love the way you explain things. Now, we are going to cut in here with another image coming from Mount Teide. This is the volcano. We've got the sun is rising, so the volcano's becoming sunlit, and we can just about see the setting moon. And in fact, we can see quite clearly when the image comes up that the moon, we've got a more current image than this coming up. The moon, you can actually see, has got this chunk out of it just as it's setting. Here it comes. Here comes this latest image. And what we're seeing here is Earth's shadow itself. Over the next 5 minutes, see this lovely pointed triangular shadow coming off there. But back
the final thing for those who might still be skeptical somehow and say, well, how do we know that's the shadow of Earth? Well, where would Earth's shadow be except exactly opposite the sun? And your images from Teide are showing that the moon is, indeed, as every full moon is, precisely opposite the sun in the sky. As the moon is setting, the sun is rising. They're on exactly opposite sides. And tonight, as we watch this eclipse, we're seeing the moon venture into the precise opposite point in the heavens to the sun.
So, Bob, a few people might be scratching their heads here. They're seeing this image that we're showing them. It's a live image from Mount Teide, which is the Canary Islands, which is where the Slooh Canary Islands Observatory is. That's where Slooh members control the robotic scopes. And we're seeing the moon setting. But when we see your live image, the moon is, virtually overhead for you now? Why are we seeing the moon in two different places? I know that sounds like a really daft question, but it's not always obvious to people.
Yes, well, further proof that we live on a ball, because if we're in one location, we're looking into space in one direction, and here in Arizona, as Matt Francis and I sit here looking at this fantastic eclipse with the giant telescope tracking it, we're over the curvature of Earth in a different direction, so that's why.
You're basically this view that we've got now is looking west across the Atlantic Ocean. You're way over there, right over the horizon, and that's why the moon's above you. So
yes,
I think that's a really nice visual description of that. Now, would it be possible for me to speak to Matt Francis, the director of the
Yes,
Prescoll Observatory?
let me put Matt on the microphone right now.
Thank you very much. Now, Matt Francis, director of the Prescoll Observatory in Arizona, does a huge amount of work, outreach work. He's passionate about astronomy. He's passionate about getting astronomy out to the general public. Now, Matt, thank you so much for generating these fabulous images that you've got tonight. Now, can you tell viewers what telescopes you're using? I know we always get a lot of questions. What telescope somebody using? What camera somebody using? What are you using tonight?
Sure, Paul. I can do that, and thank you. I'm here, and as you saw, we have basically an armada of telescopes pointing towards the moon. For the wide, the best view of this eclipse is a very full disk view, a wide angle view. So for that, I'm just using a Canon DSLR Mark V camera with a 400 millimeter lens, and I'm using
not a telescope at all for this view.
No, not a telescope at all for the wide angle full disk view. Just a very good camera and a very good fast telephoto lens. That's all we're using for that. And yeah, for the high power, we are using a 150 millimeter Takahashi triplet refractor telescope. We had that trained on the limb of the view, the limb of the moon when the eclipse started, and as Bob said, there was a gradation of darkening, and that telescope no longer shows anything but a black screen now. So it'll be after totality then when we start to see that view again.
Well, that would be great. That was a video view, was it?
Yes, yeah, live video stream view.
Okay. Now, there's a question that's come in. Are you having to change the exposure of your images as the eclipse, goes on, and as the brightness of the moon dims?
I am. I started out at 1/1200th of a second. I'm down to 1/250th of a second now at f5. So I've changed it a lot since we started. Yeah, it's less than 25% of what I had started from.
Now, I did one of these for Slooh a couple of years ago. I'm going to ask our producer actually to line up a lovely set of images that we got, which is an animation from 3 of the feeds that we did for one lunar eclipse. Now, Slooh has been around for 10 years. This is not the first lunar eclipse that we've covered. And this one is going to show us, this is a little animation that will show us exactly what we can look forward to. I hope this is the animated version anyway. So this is 3 images from 3 feeds. I think there was one in Australia, one in Hawaii, and one, I don't know, it may have been me in Cyprus or something like that. But I can remember totality. Otherwise, it just still would have looked too dark. Really, it would have looked black still. Is that kind of the feeling that you're getting? And are you starting to see any hint of color yet?
I'm not seeing any hint of color yet, but there is the rate at which I'm changing the exposure is certainly increasing. It's becoming more critical that I really watch the exposure now, because the images are darkening much quicker than they were.
And the other thing that we found actually was different people use different settings on their cameras, and what's called the white balance on the camera can make quite a big difference to the actual color that it shows up. Now, we had, I don't know if you remember this one, Matt, but I think it was 2010 maybe? No, it was 2011. And Slooh's live lunar eclipse images were included in the Google Doodle. I mean, how cool was that? This is Google's homepage, right? And these were the live images. And people could pull this little slider that we're seeing at the moment on the screen. And this is what we're going to be expecting to see tonight. So there you can see that's where we are at the moment. Then we're going to get the color coming in, and then we see the color subdued again as the shadow then leaves. So, Matt, you've got your hands full. I know we're coming up to those us here at Slooh, and I hope we enable you to reach a wider audience with the Prescoll Observatory. So thank you very much for your sterling efforts tonight.
Thank you, Paul. The partnership with Slooh certainly fulfills that goal for the Observatory of Public Outreach. And you're right, I do have my hands full, so I'll give you back to Bob.
I'll let you go. Just to remind you, this is Slooh, the Community Observatory. I'm Paul Cox. I'm talking to you from England, and we have got some fabulous images coming from our partner. That was Matt Francis, director of the Prescoll Observatory in Arizona. Now, Slooh operates online robotic observatories. Now, we haven't only just got the Canary Islands Observatory, but we also have one in Chile, and we are about to relaunch that. So suddenly, Slooh members who control the telescopes are going to be able to control the Southern Hemisphere telescopes as well. And as a kind of bit of a celebration of the lunar eclipse, a bit of a celebration of our 10th year of operation, we have got a special promotion. And we're going to talk about this specifically a little bit later, about what you can do. But the special promotion is, if you join Slooh today to control the big telescopes, you will get a pair of free binoculars. So this is a limited time offer. We can't hold it open. It's going to be while stocks last, but all you've got to do is go to the slooh.com homepage and click on the membership button, and you'll find all of the details there. Now, the Slooh community, now, I know this sounds a bit like a sales call, but the Slooh community is such a fabulous group of people. We've got ranges of expertise from people who are just starting out, who just have a passing interest in astronomy, all the way through to people who have their own telescopes but use Slooh when they've got clouds and stuff like that. It's an incredibly supportive community, so I really would recommend it for that alone, let alone the special promotion that we've got today. So please hop along to slooh.com, because it's Slooh members, it's the support of their subscriptions that enables us to put on these live public shows for everybody. Bob, you're back. How are things looking down there?
Oh, absolutely fabulous. We're about to enter, in fact, we're starting to enter the time of maximum strangeness, TOMS. Now, this is the time when the illumination on the moon no longer looks like any kind of moon that you would see during every lunar month, because the shape of the moon now, the crescent, is starting to take on an appearance that is absolutely bizarre. And from now until when totality begins, and we're talking about only another 15, 16 minutes, this, in my opinion, is the best part of the eclipse prior to totality. Now, also, there's a slight reddening, which we're going to soon see. And here in Arizona, the sky is already starting to fill with stars. We had the light of the full moon, magnitude minus 12.6, blowing out all the stars except for the very brightest. You could see Mars, you could see Spica near the moon. But now the fainter stars are starting to appear. And when the eclipse has become total, and that will happen at 6 minutes after the hour coming up, not too long from now, all the faint stars will come out again, and the countryside will be transformed.
Hey, Bob, I have to interrupt, because we've got the image coming in from the Canary Islands that we were expecting. It's not this one. This is about to update to the live image coming in, and we've just got the moon setting on the horizon, and now there it is. That's what we've been waiting for, this fantastic view. This is the shadow of the volcano going all the way down to the horizon, and just if we could see in that bright sky, that's just where the moon is setting. What do you make of that, Bob?
Oh, that's so beautiful. You know, that's called the twilight wedge, that darkening of Earth's shadow, and sometimes it's called the belt of Venus, that pink place just above it, just above the shadow of the mountain, where the final little bit of sunlight is streaming through. So we're seeing phenomena that have never looked better. They're just gorgeous, Paul.
It is, and we're seeing actually the shadow of the whole island, but just the cloud tops on the horizon. Now, Bob, this is something I've noticed whenever I'm at the observatory. You can see the main shadow of the volcano, but just off to the right, there's a line that continues off, and I always see that. Do you know what causes that?
Well, again, you're seeing the is rotating, of course, at that latitude, it's probably rotating at about 600 miles per hour in the direction of the shadow. So Earth is casting its own shadow on itself, and you can only see it clearly at that time of the evening. But I'm seeing what you're talking about from here. I'm a little distance from the screen.
Okay.
More than I'd like to be, but yes, I can see the mountain tops shadow. Yes, beautiful.
We'll pick that up. I mean, this is a totally unique view, and this, by the way, is provided courtesy of our partners in the Canary Islands. It's the Institute of Astrophysics in the Canary Islands. They manage the world-class observatory site where Slooh's telescopes are based, and we have a half-meter telescope, and we have a high magnification planetary telescope, and a small wider field telescope as well. And those are the telescopes that Slooh members control every clear night. And because we're above the clouds most of the time, it's a cloudless night, and the views we get there are absolutely stunning. We're going to take some questions now. Don't forget, you can ask questions by using the hashtag Slooh, SLOOH. And I'm going to ask our producer, actually, just before we move back to the lunar images, to maybe dig out a few of the live images that Slooh members have been enjoying tonight, maybe of some of the other objects. But, Bob, we've got a couple of questions here. How often does this eclipse happen? My son's only 8 months old, and this is going to be his first. Will he see this again when he's older?
Yes, when he's only a few months older, because it just so happens that this is one of those rare years. It only happens a few times a century when there are two total eclipses of the moon, both visible from North America. So on October 8th, we'll get another one. That one, if you think you've stayed up late for this one, that one will be even closer to dawn later on in the night, but nonetheless 2 in a year. Sometimes we will go 3, 4, 5 years without any. So it's variable. And total solar eclipses rarer still. We will, it's too early to talk about the August 21st, 2017 total solar eclipse in the United States. That will be the first one in 38 years where the shadow will cross any part of the mainland United States. Those are rarer still, but still a lunar eclipse. And right now, we have fully entered the time of maximum strangeness of the eclipse, and the reddish color is starting to emerge a little bit. I'm not sure we can see it yet on the Slooh monitors, but those of you who are outdoors watching this live, since we're also narrating it for you, there's the first hint of the red color of Earth's shadow, and it's just quite amazing. There's not too much of the moon left.
Now, Bob, we can't quite see that happening in the live images that are coming from the observatory there at Matt Francis's Prescoll Observatory. But hopefully we're going to see that. But we've got a couple of associated questions. Now, we are waiting to bring on our next guest, Michael Narlock. He's the Slooh educator, and he's going to be telling us about this fantastic new program that we're launching, Slooh Classroom. It's part of our 10th anniversary celebrations to get Slooh and the control of these telescopes into classrooms, certainly in the USA. But there's a couple of, I don't think it's the right time, Bob, to switch over to Michael. I think we need to see this part of the eclipse through. So we'll stick around. And there are some associated questions. One's coming from Caitlin, and that's, I'm going to ask this is from two people, but they're associated questions, Bob. So Caitlin asks, what exactly makes the moon go red? And Haley asks a similar question. Why doesn't the moon start to turn red as soon as it goes dark? Why does it have to go completely dark first?
Great questions. The reason it will turn reddish, and it's still very subtle to the naked eye, is that the Earth's shadow is not a black shadow. It's a red shadow, and it's red because there's a ring of our atmosphere. All of the world's sunrises and sunsets together form a glowing, like wedding ring that surrounds the pitch black Earth. If you were on the moon right now, you'd see a pitch black Earth, but with a bright red ring of sunrises and sunsets. And that's the light that's hitting the moon. So the red skies that you see at sunset and that we've just shown you, in fact, on the Canary Islands, only that section of the sun's light is hitting the moon. And the reason you didn't see it at first is that our eyes, and the cameras and the equipment that we're using here have to take the correct exposure to include the bright part of the moon. And the sunlit section of the moon before totality is so bright that it will underexpose, and your eyes do the same thing, underexpose the dark part.
And
so
this is
you'll
exactly
see it
what
as
we're seeing now, Bob. The latest image that came in, we're suddenly seeing that darker part of the moon. So Matt's changed the exposure on the camera. So that the lit part of the moon is slightly overexposed, but Matt's done that so that we can start to see it, and I can see some very faint color in this. Now, Bob, as I said, we were due to have Michael coming in. Now we're going to get Michael into the show, but I think we'll stay as a group until we see the total phase and that full color come into view. Does that sound like a good plan?
Yes, it sounds like a great plan. And one more thing to look for is that since we have Mars in the sky to the upper right of the moon, just before totality, when we have one last little tiny bit of white sunlight on the moon, it's going to resemble Mars, because the part of the light hitting the moon will look like the Martian polar cap, which is brilliantly white. The rest of the moon will very closely match the color of Mars. And as, of course, you know, because we just did a show earlier tonight, this is the night when Mars has come closer to Earth than it has in the last 6 years. And the stunning coincidence that we have a total eclipse of the moon when the moon's turning red on the very night that Mars is closest and is next to the moon in the sky just makes it even more beautiful. And if you want something even more beautiful, and you happen to be in a place where it's clear, look right next to the eclipse moon and you'll see a blue star, the brightest star in Virgo, Spica, one of the bluest stars in the sky. So you've got everything tonight on this eclipse.
The contrast of the three is absolutely fabulous. We are now going to welcome into the show Michael Narlock. Michael, can you hear us?
I sure can.
Welcome back to Slooh. Now, you are officially the new Slooh educator, and you're launching this fantastic new program for us. So first of all, tell us where you are, and tell us if you're looking at these fabulous live images that we've got, or whether or not you've got cloudless skies so you can actually see it yourself.
Well, I'm broadcasting from Michigan, where it's snowing right now. So the best I can do is to take a look at the images that Slooh's broadcasting, and that's not too shabby. I can start to see the reddening already. It looks absolutely marvelous.
Absolutely. Now, you're going to tell us a little bit, I think, about this new program that Slooh are launching. So what's Slooh Classroom?
Well, it's really an effort to bring Slooh to K-12 students and teachers. We're going to be doing sort of bite-sized astronomy educational nuggets every week that the teachers can use in their classrooms to get ideas for activities associated with the wonderful images and celestial opportunities that we have, and also for students of all ages to learn a little bit more about the nighttime sky using really 10 to 15-minute bite-sized nuggets.
And you're going to be broadcasting these shows, presumably with live images from the Slooh telescopes?
Absolutely. We're going to tie everything that we do in with what Slooh's able to show us, from astronomy 101 basics, using the all-sky cameras to sort of start things off with how the ancients looked at the sky, all the way up through looking at the faint fuzzies that you can see in the nighttime sky.
Syllabus in the United States, is that correct?
Yeah, the United States is in a bit of flux right now in terms of educational standards. There's one called the Next Generation Science Standards, and we're trying to tie Slooh Classroom in with those new standards so that teachers who, obviously have a lot on their plate already can get a bit of a leg up with astronomy education, because we're going to have some prepared modules and prepared segments that they can sort of dip into and use to augment what they do in the classroom, or to supplant some of the old things that they used to do in the classroom.
I really don't think there's a better way to celebrate Slooh's 10th anniversary than to get into classrooms like this. Now you your day job is you're head of astronomy, aren't you, at the Cranbrook Institute of Science? Is that correct?
Yep, I am the head of astronomy at Cranbrook, amongst other things. And actually, I used to be involved in Slooh back in the day. For about 4 or 5 years, we did a Slooh radio program on Slooh.
Incredibly popular
from
as well.
there. Yeah, it was a lot of fun, and I'm absolutely thrilled to be back. It's Slooh and its robotic telescopes are an absolutely wonderful resource that everybody, from amateurs to professionals to just enthusiasts, should dip into.
Well, that's another aspect, actually, that we haven't discussed tonight. Just as we see this wonderful live image coming in from the Prescoll Observatory in Arizona, Matt Francis, the director there, controlling his telescopes. This is a DSLR camera with a long lens, giving us this particular view. We got Bob Berman, the Slooh astronomer. He's in the observatory tonight. So I don't know. We'll see them. We'll see their webcam view a little bit later. They're wrapped up fairly strongly. Now, Michael, you're going to take a kind of short classroom session once we get past this bit of the phase when we see the color coming in. Is that right? You're going to take us on a 15-minute classroom session or something?
Yeah, we're going to take a look at the eclipse from the perspective of what could you do with it in the classroom. Are there any activities you could do? What's really going on? And I will tell you, I was listening in before to your discussion with Bob. I could listen to him read the phone book. He's got such an encyclopedic knowledge, and we're going to basically use some of the information he was talking about, but put it more into how a teacher could use it in the classroom context.
Well, Matt Beatty, who messaged us earlier, don't forget you can fire questions to me, to Matt Francis, to Bob, to Michael Narlock, any of us here, just using the hashtag Slooh. And this is what the boys have been staying up for. So you've already got at least a classroom of 2, but actually I know we have got people from all around the world tonight. But I love the fact that some parents have kept their kids up late. If there was ever a reason to stay up late, then
yes. And this is it. And gentlemen, if I can just interrupt for just 15 seconds.
Absolutely.
I love listening to Michael as well, so it's a mutual admiration society, I assure you. But just at this moment, this is it. Totality is about to start, and just look at this strange, weird moon as the tiny bit of sunlight is hitting the right side of the moon. We're only a few minutes down from totality, and just fantastic, isn't it?
It is. It's absolutely glorious. And Matt Francis there at Prescoll Observatory, you are doing a wonderful job. Now, between Bob Berman, Slooh astronomer, and Michael Narlock, Slooh educator, we've got some questions that I'm going to fire at you. Now, this is not a buzzer round, all right? The first question, I think, goes to Michael. And this is it. This is from Barefoot Sommelier. And the question is, does atmospheric pollution deepen the reddening of the moon?
Absolutely. The more particles basically you have in our atmosphere, the darker the shadow is going to be, the more reddish it's going to be. I recall some years ago there was an eruption of, I think, Mount Pinatubo, and it resulted in all the particles that had shot into the atmosphere resulted in a very dark, almost eerie blood red moon. So yeah, the more particles you put into the atmosphere, the redder our shadow is going to be, and the more ominous the total eclipsed moon is going to look.
That's right, and it also matters about your altitude. Now, strangely, there's a very close to the Slooh Observatory in the Canary Islands. They're kind of adjacent. They're our neighbours there. Is what's called the Earthshine Observatory, and what that observatory does is it's kind of taking images like this. It's the unsunlit portion of the moon, and what they do is they measure the brightness of that, and what they're measuring really is the clarity of the atmosphere. So there's there's an awful lot going on at these observatories that people don't really know about. Now, Bob, I got another question here for you. I'm sorry to ask again, anyone, do you by chance remember what they said was going to show on August something 2017, first one in 30 years? That's a solar eclipse, isn't it, in North America?
Yes, that's the first time in 38 years that the moon's shadow itself will land on Earth. A total solar eclipse. We've had annular eclipses, but not a solar one. And this will be coast to coast from the Pacific Northwest all the way to the Carolinas, and quite an event that we're looking forward to now. A total solar eclipse makes people leap. It makes animals go crazy. And it's a life-changing event. This is really wonderful.
Now sorry, Bob, a solar eclipse, unlike a lunar eclipse, which is kind of visible from one half from the west coast to the east coast, is that right?
Yes, from northwest to southeast. It always moves somewhat eastward, because if you think of the direction of the moon's orbit around Earth, and then Earth is also rotating in the same direction, you have to have that shadow moving eastward, but move northeast or move southeast, or and sometimes it's even due east briefly. So, yes, that will be the case there. And because the path is so narrow, it's rare for any one given spot on Earth to have a total eclipse. Usually, on average, 360 years must pass if you're a stay-at-home kind of person and just want to wait for a total eclipse to come to you. Of course, if it's cloudy, then you have to wait another 360 years. So it's a good idea to try to travel to see one. And it's just an average. Los Angeles is in the midst of a 1,000-year hiatus of no total solar eclipses right now.
But don't worry, if you're not in that path, if you're not in North America, don't worry, because Slooh will be here, I guarantee you, in August 2017, and we will be showing you the solar eclipse live, just as we are showing you this total lunar eclipse. And now, Matt Francis at the Prescoll Observatory, we are seeing this lovely peachy, coppery color just starting, and that's going to redden and redden and redden. So we're going to carry on looking at this. Michael, do excuse us. We're going to put off your classroom activity until we see this phase of the eclipse through, and then you can take over and take your first class. Now, there's a question that's just come in from Tawny Morin, and they are asking, will the Slooh classroom be available in Canada, and when could it begin to be offered? Now, of course, anybody who uses the Slooh telescopes can use them anywhere in the world. So is that the same thing for Slooh Classroom?
Absolutely. Slooh Classroom will be available on the website as an archived experiences, but it'll also be available live when we create the program. So absolutely, wherever you can get Slooh, you can hear my dulcet tones babble on about astronomy.
Perfect. And of course, the big advantage here when it comes to schools in either North or South America is that the Canary Islands Observatory is just off the west coast of Africa. So it's dark there. What, a full 5 hours, maybe more, than the East Coast in America. So, kids haven't got to stay up late to be able to see live images coming in from the telescopes that you and the Slooh classroom project is going to be showing.
That's absolutely right. I mean, it's the telescopes in the Canary Islands and the Chile telescope. When Chile comes online, and when we use the Canary Islands, they're almost positioned perfectly for North and South America to use in the classroom. But that doesn't mean that if you can't listen in live when we're doing a broadcast, that's why we're making a library essentially that hopefully we'll be able to group the different modules together into different themes. So if a teacher's doing something on stellar evolution, maybe they'll group a bunch of our modules together where we talk about Betelgeuse or the sun or things of that nature, and they could piece them together on their own to create experiences for the students that they just normally wouldn't be able to do.
Excellent. I am so looking forward to it. I mean, you've got a viewer for the Slooh classroom here straight away. I mean, I'm first in line. But also, alongside this, we are launching this week to a few users, and then over the next couple of weeks, launching it out to all Slooh members, this new collaboration and communication system. It's where Slooh members can meet, can chat, can share their images. And don't forget, when any Slooh member controls the Slooh telescope, everybody else, all of the other members, can watch the live images. So when you control the Slooh telescopes, you can choose one of two things. These are the telescopes that we're seeing at the moment in this image. You do one of two things. You kind of select when you want to control the telescope, and you select what object you want to view. You can view it live. Slooh has some patented technology which processes these astronomical images live, and maybe our producer will show us a couple of examples, maybe the Orion Nebula or something like that. It processes these images in real time, so you can watch it as the Slooh telescope is pointing because you controlled it, and then you see these wonderful images coming in. Or if you can't stay up that late, or it's not convenient, you just tick a little box and the telescope will automatically take that picture for you, and it'll put it in your own area. And then with this new system we're rolling out, you'll be able to share it and talk about it and do loads of other things with the rest of the community. It's a fabulous system. And Michael, you're going to be taking over and managing this school classroom part of that system, aren't you?
That is what I've been told.
Yep, I tell you, it's going to make your life so easy. Now, Bob, I've got to come back to you because we've got to come back to this live image of the lunar eclipse. This is from the Prescoll Observatory. Matt Francis, we can't talk to him at the moment. He's actually sitting next to Bob Berman, but Matt has really got his hands full. This is the latest live image, and Matt's having to change the exposure time rapidly at the moment as the moon is going into what phase, Bob? What are we seeing here?
It is now totally eclipsed, and some people may be puzzled because the lighting is uneven. One side of the moon looks brighter than the other, but it's no longer direct sunlight that's hitting the moon. Rather, if you were on the side of the moon that looks brighter, you're in a place where a little bit more of the glow of Earth's atmosphere, a little sun, is indirectly getting to you, and in the darker parts of the eclipse, which will envelop the whole moon as we watch in the next 40 minutes. It will be fully enveloped in that deepest part of the darkness. That's where the Earth is more centrally covered. Is seen at its dimmest.
Well, Bob, I think on that note, do you think now is a good time to hand over to Michael Narlock, the new Slooh educator, to kick off the Slooh classroom program?
Oh, absolutely! I'm looking forward to this. Yes, absolutely. Let's hear it.
Excellent, Michael. Are you ready?
I'm as ready as I'll ever be.
Well, as we say, break a leg. We will still be here as soon as you finish or anything else. So don't worry, and we are looking forward to it. Enjoy. This is Michael Narlock, the new Slooh educator. This is part of our new Slooh classroom program. Over to you, Michael.
All right. Well, thank you very, very much. This is actually the second Slooh classroom. We did a Slooh classroom module last week, and in conjunction with the Mars opposition, and I'm quite fortunate actually to have the Mars opposition as our first opportunity, and now this eclipse event, which is just fantastic. The eclipses are probably the easiest and most accessible celestial event that the whole family can enjoy, that students can take part of. They're probably not quite as impressive as a solar eclipse. Again, we have one of those coming up in North America in 2017, and if you've never experienced one, it is a very an interesting experience to be in during the day, and then all of a sudden everything gets dark and you'll actually hear a change in the bird song. Those are fantastic event, so look forward to that in 2017. But certainly from a visual point of view, a lunar eclipse is impressive because, as we've been talking for the past half hour or so, the fact that the moon goes from this silvery bright orb to sometimes this deep reddish moon, and it's inspiring, especially for young kids. I have 2 young kids, 7 and 4. They are fast asleep right now, I'm afraid, which is probably okay since here in Michigan, as I mentioned before, it is snowing. But one of the things you can do, because a lunar eclipse is so visual, is you can do your own time lapses of a lunar eclipse. And what you can do with a simple paint program that you can find on your PC or Mac is stitch together the various images of a lunar eclipse, and you can actually create for yourself a mosaic that shows you how big the shadow is that the Earth is casting. Now, I have an image that I believe it's a NASA image that I found online today that I'll have the producer put up, so you can take a look at what I'm talking about. So this is a series of images of not this eclipse, but a previous eclipse, and they're sort of stitched together. And what you can see is once you stitch them together, you can actually see how the Earth's shadow plays across the face of the moon. Now, this is a relatively basic, simple little experiment, but one that you or a teacher or a student can do in the classroom. And you can actually see the Earth's shadow in a visual way. So you can sort of bring home how big the Earth's shadow really is. As we mentioned before, the Earth's shadow extends about 1 million miles into space. And the only object of size that happens to be within that distance is our moon, which is about 250,000 miles away from the Earth. So you can see exactly how big the shadow of the Earth is. Now, what you may get as an educator or a teacher or a parent, the question you might get asked is, why exactly is the moon red? Why isn't it blue? Well, as we mentioned before, the Earth's atmosphere is acting as a bit of a filter. And during the day, you might notice that your sky is blue. If you happen to be fortunate enough to live in a place on the Earth where you actually get clear skies, the sky is indeed blue. Blue light tends to be scattered more than other wavelengths of light, so that's why our sky appears blue. Red light isn't scattered so much. So our sunsets and our sunrises tend to be reddish, and the ring of atmosphere that the sun's light passes through before it hits the moon tends to be tinged red. And the more particles, the more debris, the more pollutants in our atmosphere, the redder that light is going to end up being. So what we get during a total eclipse is a very red moon. And as we look at, I believe we have about exactly how beautiful the moon does look when it's bathed in red light. And one of the things that you can do that's always fun is take a look at those dark areas on the moon, the Maria. And this is where you might see images and shapes in the moon. There are a couple of important ones. Some people see a rabbit in the moon that goes back to Native American mythology. There's Betty Rubble, believe it or not, you can find in the moon. You can find a poodle in the moon, just looking at those dark areas. So when you actually cut down the amount of reflected light from the moon, you can actually, at least my eyes anyway, can see those dark areas a little bit more. So that's just a few things that you could do in the classroom if you're so inspired. Now, once we get the Slooh Classroom section of the Slooh website up, we'll be posting written activities that you can download and use in your classroom, and other resources that we talk about or that I might create on the fly during one of these Slooh Classroom sessions. So we're very, very excited about those new opportunities as they become available. All right. Is Paul available? Okay. So Bob, how's the weather out there? I noticed you were all bundled up. All right. I am apparently on my own, so you'll forgive me if I start singing a song. So right now, let's see. Sure, put that up. The science of the laboratory is available to everyone. You know, a chemist needs a laboratory, a biologist needs a laboratory. Our laboratory is the nighttime sky, and even if you live in a city, you still have some things that you can see in the nighttime sky. Now, the technology you bring to bear or the resources you have certainly will play an important role, but nevertheless, the sky is available to everyone.
You're right. It's so accessible, isn't it? I think we may have lost Michael there. I maybe cut him off. Listen, I'm going to give you a quick update because we are going to tell you exactly what we've got left for the remainder of this show as we are looking at this fabulous, peachy, live moon under the total solar eclipse. Now, we still have a long time to cover this. We are going to be with you for the whole of this total lunar eclipse. This is Slooh. We are the Community Observatory. Now, we have observatories in the Canary Islands, which is off the west coast of Africa. That's our flagship observatory. And we are just about to relaunch our Chile observatory, which means that Slooh members, they subscribe to Slooh, they get to control the telescopes, they pick a time slot, they choose where they want to point the telescope, and Slooh automatically does the rest. Now, it's not just beautiful images either that Slooh members take with the telescopes. We've got some teams who are monitoring near-Earth asteroids, and those of you who are familiar with Slooh will know that Slooh were invited last year to NASA to participate in the near-Earth asteroid Grand Challenge, and we're still working with NASA on that, and we've got some fabulous Slooh members who do that kind of real science, but you don't have to be that advanced to join Slooh. Sign up. You can take an image of the moon, you can take an image of a galaxy, you can take an image of an asteroid, you can take an image of Jupiter, Saturn, anything you like. You can point the telescopes wherever you like. And we have got a very special promotion to celebrate not only lunar eclipse, but also our 10th year of operation. Now, if you join today, it's Tuesday here, so it's really over the next kind of 18 to 24 hours, you will receive a pair of free binoculars. Now, I want to talk to Mr. Bob Berman. Sorry, Bob Berman. He's not Mr. Bob Berman is a qualified professional astronomer. I'm sorry, that's my Englishness that just keeps putting that
fine.
Mr.
I'm great to be back. And isn't this eclipse wonderful? Isn't it just absolutely
beautiful,
stunning?
Bob? Now, tell me, is that live image very representative of the color that you're seeing there in person?
Yes, it is.
Yeah, I thought it would be with we're really enjoying. Now, I want to tell, before we talk to people about how they can use these binoculars, and this is not a sales bit, this is actually a bit of an education bit as well, because this is, if you own a pair of binoculars already, we're going to tell you what you can do with a pair of binoculars and how you can use that in combination with using the Slooh online telescopes. But first of all, I want to tell you that we still have some fascinating stuff coming up. We have Jeff Fox coming up. That's a little bit later. That is in about 35 minutes time. Now, Jeff Fox is an ex-weatherman. He's going to be a new Slooh host, and he's going to be producing some of our live shows in the future. So we're going to be talking to Jeff, really to introduce him to our audience tonight. And our audience tonight is global. We know we've got people from around the globe looking at this live lunar eclipse with Slooh. And I'll tell you, you've either got up really early or staying up really late. So if you've made it this far and you're seeing this beautiful peachy copper moon, it was worth the wait, wasn't it? But we have also got a fabulous discussion that Bob recorded the other day with Duncan Copp. Now, Duncan is an astronomer, but he's also a documentary filmmaker and a great Slooh friend. And Duncan has been responsible for some of the great lunar and moon documentaries. He did, which one did he do, Bob? It was In the Shadow of the Moon.
In the Shadow of the Moon, yes.
And that's an award-winning film. Now, if you haven't seen it, I would highly recommend you try and get to see In the Shadow of the Moon. Bob, tell us a little bit about that film, because it actually spoke to an awful lot of the people that you yourself have interviewed over the years, astronomers and other luminaries at NASA.
And astronauts, yes, astronauts. What Duncan did was he was able to actually get his paws on many of the astronauts who walked on the moon and really conveyed a sense of what it was like to be on the moon. I think he really captured it beautifully. So In the Shadow of the Moon is wonderful. It was in the theaters. Nowadays people can get it, of course, by ordering it on DVD rather, on Netflix, pretty widely available. And Duncan is a wonderful speaker and a very modest man, very modest. If I allude to him as an astronomer, he'll say, well, I don't really do research now. But, you know, he has a PhD with a specialty in planetary geology and in particular Venus. And they don't hand those out every day. And so he's not just a person with a camera making these documentaries. So we'll be hearing his interview in a few minutes, I think. Right?
And it's always fascinating listen to you, Bob, talking to Duncan. So we've got that coming up. But before we do that, we've got one question, and then we're going to shift to how people can use binoculars, especially when it comes to viewing the moon, Bob. And the question is, this is from Priestess Candy R, and she says, what time will Mars, Earth, and the moon be in line with each other, and how long will it last?
Well, they were in a straight line with each other 12 hours ago. The moon has already passed Mars. Now, even though and it's very interesting that they're in the same part of the sky. In my entire life, in our lives, we have never seen a total eclipse of the moon on the same night that Mars came closest to Earth, that Mars was at its very brightest, in this case the very brightest in 6 years, at the same time that the moon turned its coppery red because of an eclipse. So this is a astonishing rare occurrence. Mars is at its closest to Earth, essentially, or within a few days of its opposition, meaning that, to answer this caller's question, viewer's question, the Sun, the Earth, and Mars are in a straight line when Mars is closest. Okay, an eclipse moon can only happen at full moon, when the moon is opposite the sun. So Mars comes closest to us when it's it had to be. If Mars is at its brightest and the moon is in eclipse, they needed to be near each other. But the exact time of closest to each other physically in the sky, that happened 12 hours ago before the eclipse began.
What a night we've had here, Bob, at Slooh. We've had the live show. We had Rob Manning from the Jet Propulsion Laboratory. We were talking about Mars being its closest to Earth in the last 6 years. And now we're watching these fabulous live images of the lunar eclipse. You're sitting in the Prescoll Observatory with Observatory Director Matt Francis, generating these beautiful, beautiful images. Now, we are kind of changing our scheduled program here, Bob. I'll probably get in lots of trouble, but we're deciding with our producer tonight that we can't give you a recorded interview while we're getting these fantastic color images of the moon. So we're going to kind of put that back a little bit. We're going to invite Jeff in maybe over the next half an hour sometime. So, Bob, let's go back to what we have been promising viewers all night.
And I'm so glad you're doing that, because binoculars are, if I were outdoors and not using Slooh, if I had clear skies tonight and we're going to observe this directly, there is no instrument that shows better than. So binoculars are the ideal way to observe many celestial events. These particulars that we will be giving as part of this promotion with their 70 million lenses are unusually bright and unusually appropriate for astronomical use. I mean, too many people use the wrong binoculars that might be good for bright light or sporting events, but you want a very big lens and you want a magnification that's appropriate for that lens. In this case, these binoculars that we are giving are 12 by 70. If you divide the first number into the second, you get the exit pupil, which the brightness of the image. In this case, 12 into 70 is about 6, which I regard as absolutely optimum in the pair of binoculars that are going to be used for astronomical purposes.
That's right. I mean, these are large binoculars. We'll come on to that. But I've just been reminded, Michael Narlock was still hanging on there. I think we've lost his audio. But Michael, thank you so much for introducing yourself as Slooh educator and the Slooh classroom program for us tonight during this lunar eclipse. We are so looking forward to your weekly enterprises with that particular project. So every success to you on that, and no doubt we'll speak later on in the week about that. So, Bob, back to binocular astronomers. Now, one thing that I am often asked, I know a little bit about astronomical equipment and telescopes and CCD cameras and all that kind of stuff, and it means I'm often asked by people, what kind of telescope shall I buy? And I think you can guess my answer, can't you?
Well, the answer I would hope that you would give, the answer that I would give, is that it is better to have a good pair, an appropriate pair of binoculars, than a telescope. And
Absolutely.
Even if you want a telescope,
Absolutely.
Get the binoculars first and use them.
And that's what I always say. And, you know, what we're not doing now is we're not going to mix up this conversation with the promotion that we've got, that if you join Slooh, you get a free pair of binoculars. There, you've got that information. We're just going to tell you about astronomy with binoculars. We're going to carry on watching these fabulous live images of the lunar eclipse as it turns redder and redder. But Bob, that's exactly what I tell them. And the reason why I tell them is you go into a shop and you see these lovely boxes with a telescope in, with beautiful color images on the outside. And there are so many of those telescopes, actually even bigger telescopes, that actually stay in their boxes in a cupboard somewhere because they're either too difficult to set up, they take too long to set up because people haven't got a permanent observatory. They're probably under clouds. They probably have to get up for work in the morning. And the reason why I always recommend a pair of binoculars is because looking visually through a telescope so often disappoints people with all but the moon and the planets. Is that something you would agree with?
Absolutely. In fact, over more years than I'd like to admit, people have, well, I charge a fee for this, help them set up their telescopes and show them how to use that, give them an hour's worth of instruction, and people think that a telescope with a go-to capability, they can just press a button and it'll point to amazing objects in the sky. And the truth, the sad truth, is there are only about a dozen objects that look genuinely stunning through a telescope, and you have to be able to find them. The only one that's easy to find is the moon. Everybody can.
Well, let's just cover that, Bob, because that's quite a big statement there, and I would probably list the things that are good to look at through kind of any size telescope, but certainly a big one. I certainly don't bother at all with a cheap small telescope. Just don't bother. Don't go there. If it's a bargain, if it's $100, if it's a few $100, don't go anywhere near it. But I would say the moon looks stunning. Don't look at it when it's full. Look at it when it's at its partial phases, because you get all the lovely shadows. Look at Jupiter. Jupiter, you can usually make out the bands, possibly the great red spot, but even with a pair of binoculars, you can see all four of the Galilean moons, my favorites. Everybody knows, if you've watched Slooh, Jupiter is my favorite object in the solar system. It's so dynamic. But Saturn, you can make out the ring system in a pretty good telescope. But then the other thing that I would add to the list, Bob, is globular clusters. And I think they do look fabulous. They're bright enough. These are, well, Bob, what is a globular cluster? Why do they look good through a telescope, whereas galaxies and nebulae don't?
Yes, well, a city of suns, where up to 1 million suns packed into a ball shape, only about 200 light years across, dense in the center, loosely packed on the edges, one of the most stunning things. And if we're talking about binoculars versus telescopes, we have to tell you straight up that it's apples and oranges, because some objects simply look better at lower magnification than do, and some objects require a higher magnification. A globular cluster, you will not see that through binoculars. You need a telescope. On the other hand, if you really want to see the Pleiades, star clusters, Seven Sisters, or the Milky Way, or many other celestial objects, you must have a low power, a wide field, and also the stereo view, the idea of using both eyes and able to keep both eyes open. The restfulness of that and the three-dimensional sense makes binoculars peerless, better than any telescope when it comes to spread out objects. I'd say the Andromeda Galaxy, again the Pleiades, other open clusters, the Hyades, the Milky Way in the summertime. These are objects, especially under dark skies, that are fantastic, and that no telescope will equal that view.
Well, what I do add to people, Bob, when they ask me what telescope shall I buy, is I say, and this, look, folks, this sounds like a big sales push. It's not. This is just my honest assessment of the situation when somebody asks me, what telescope shall I buy? I tell them, buy a good pair of binoculars. This pair of binoculars is a fabulous pair of binoculars. You will recognize the name when you receive them. We're not actually telling you that. But the other thing that they should do is join Slooh, because you can then use a telescope. Just one of our telescopes costs about $35,000. The CCD camera that goes on the back of it, this is a highly sensitive research-grade telescope that goes on the back of it. You can spend £15,000 on a CCD camera, let alone having a dome, another $40,000. You know, that's the equipment that you're using, and you're using it not under the cloudy skies that unfortunately most of us live under, but you're using it at a world-class observatory site. So you get to use these fantastic, expensive, scientific-grade equipment, but then you also have the joy of going out in your own backyard. And I think it is important, don't you, Bob, that you have that one-to-one connection with astronomy sometimes, that you are physically looking through the optics of
very
something.
much so, very much so. Those who have binoculars, I would even say, you know, don't tear yourself away from Paul right now while he's speaking, but some point during the night, if you have clear skies and you do own binoculars, do take a look at this eclipse moon through binoculars, because the best views are that wide field view. I want to say one thing else. If you're going to have astronomical binoculars where the views are both bright and a little bit more powerful than regular binoculars, do brace your elbows on a hard surface, a windowsill or a car.
Well, Bob, I was going to come on to this, because this is a really important aspect of the binoculars actually that we're giving away free. These are 12 by 70s. These are large binoculars. Now they do have with them a tripod screw, so you can either put it on a monopod or a tripod if you've got one. But actually, there are other ways that you can do it without the means of a tripod. And the way I use my large binoculars is, once again, I lie back in, just a sun lounger chair, and I put my elbows into my chest, and you can hold the binoculars tight. But because these are 12 times magnification, you do have to hold them steady. Now, these are large binoculars. They weigh, I think they're 49 ounces. And Bob, one thing I'd like you to explain to people is this particular pair, they have a field of view of 4.6 degrees. Wonderful. What does that mean? How's the moon going to look in a field of view of 4.6 degrees?
Well, that's wonderful, because the moon is half a degree. So it means the field of view is wide enough to take in 9 full moons at a glance. So it's a picture window. Instead of imagining yourself looking through a little porthole optics, a small circle of view, we call it a field of view, you have a picture window view, a wide field of view. And what you said before, I regard as very good advice, Paul. 10 magnification, I've always considered close to the upper limit of what you're going to see steady without shaking. This is 12 power, so it's not crazy to hand hold it or to brace it against your chest. These are not 20 or 30 magnification where you'd have no hope of using these, just holding them in your hand. But yes, you could, because they do have a thread. Most binoculars don't, but these have a thread and will fit on any standard tripod, even a little cheap one.
One of the best pieces of advice I got from my local astronomy club when I first joined was one of the old hands. He said, look, best tip I've got for you, get a broom, hold it upside down, and use that to put your binoculars on. And it works like a treat, Bob. An absolute treat. We've got a question.
Are you saying putting the binoculars on the broomy end, on the
broomy end? That's right. You put the stick end on the ground, so you have a nice surface on the top, and it's just at the right height for you.
I've never heard that, Paul. That's I'll bet that would work. But you know what? I think you should get a new broom, a clean broom, not a dirty.
Actually, you can get mono tripods really cheaply now. Bob, we have a question coming in. What determines when an eclipse will occur? How did we know it was going to happen tonight? This is from Elizabeth Fairbanks. Thank you for joining us tonight. Elizabeth, if anybody else, by the way, wants to ask us a question, just use the hashtag Slooh, SLOOH.
Well, as the Earth goes around the sun, if the moon went around the Earth in exactly the same flat plane, like a CD or a DVD or a vinyl record, we'd have an eclipse every single month, because the moon would venture into Earth's shadow. But its orbit is tilted just a little over 5 degrees relative to the Earth's orbit around the sun. So that means usually it will pass above our shadow or below our shadow at each full moon. But there are 2 crossing points or nodes in our orbit around the sun and the moon's orbit around the Earth, where if it's full moon, then it has to venture into our shadow. And this is very well known. And the moon's period of going around us relative to where the crossing points are of the nodes, which are 27.21222 days. I happen to remember that. That period can easily be kept track of, and we do keep track of it. So we know which is going to be the full moon, where the moon happens to be aligned in all 3 dimensions, in the flat plane of the Earth and the sun and the moon's orbit. And then there must be an eclipse. That's what's happening tonight.
Now, Bob, we are watching the live images coming in from the Prescoll Observatory, where you are now with Matt Francis, Observatory Director Matt Francis. And what we're seeing now is we are roughly midway through the eclipse. I think we're midway through the eclipse in another couple of minutes, aren't we?
Yes, and that's why the moon is looking more uniformly dark. Yes, it's got a more uniform appearance. Wouldn't you agree than it had earlier tonight? In other words,
absolutely. And I think Matt will be increasing his exposure time just as that last bit of the kind of more illuminated part of it.
Yes, and we're seeing the true color. I'm looking out through the dome. This is a giant telescope in a giant dome. We have our jackets on. You know, we're up almost 6,000 feet here ourselves in the very dry air. The dew point is 2 degrees, 2-degree dew point. So extremely dry air. And as I look through the dome, as I speak to you, and I look at other images that we're sending out, the colors match perfectly. So we're really sending you a true image. And during the day today, much of the media were saying that this was going to be a blood moon. And all along, well, we knew, astronomers knew, that this is more honestly orange than a blood red.
What I've seen in the past, Bob, is some astronomers, so that they can get their lunar eclipse images published, they actually change either the settings on their camera or they process the image afterwards to increase that saturation of color. And that obviously makes a far more, spectacular image. But really, when we're looking at this, it doesn't need any enhancement to make this spectacular. I mean, we just have to understand what's going on here. The moon passing into the Earth's shadow cast by the sun. But there are 2 parts of the shadow, aren't there? So people who have joined the broadcast late, maybe explain to them once again. We used 2 terms earlier. We used penumbra and we used umbra. What do those 2 terms mean, Bob?
Well, the penumbral shadow is essentially the place where if you were standing in it, you'd see the sun partially obscured by the Earth, but still very bright, brilliant sunlight would still be reaching you. The umbral shadow is where the Earth is totally blocking the light of the sun, and therefore no sunlight is hitting you directly. And that's what we're in now. We're fully in the umbral shadow.
And this is going to last for how much longer? When does it poke out into the penumbra again then, Bob?
We've got another, 35 minutes. We've got another 35 minutes of the total part of the eclipse.
So what are we going to see in 35 minutes?
Even stranger and freakier than totality, although this is just absolutely gorgeous. And those of our viewers, our listeners who are in the clear tonight and maybe watching this from time to time through their window, but also seeing this at Slooh, they will be able to attest. And it's rare, Paul, isn't it, for our viewers to be able to look at the event themselves, just with the eye, look at their computer monitors and see how we're presenting it, and say, yes, those Slooh people are really showing it as it really looks.
It is.
Because many of our events, let's face it, we're bringing comets that require very fancy equipment, the Slooh equipment, asteroids that are so dim that there's not a chance of you seeing it yourself from your backyard, and other Saturn with its rings, galaxy showing the spiral arms. We're showing things that people are not going to see themselves and be able to compare to the reality to the Slooh image. Tonight is different. Tonight, if you're in the clear, you can look at both and see for yourself whether we're doing a good job of bringing you a realistic view of how this looks. And I'd say, yes, we are.
Absolutely fabulous. And thank you very much to Matt Francis, director of the Prescoll Observatory, who is giving us these fabulous live images. Bob, interesting you mentioned comets there, because the last 2 missions using the Slooh telescopes tonight were 2 comets that look absolutely fabulous at the moment, and they are comet C 2012 K1 Pan-STARRS and C 2013 R1 Lovejoy. Now, last year we were all rather disappointed, weren't we? Comet Ison kind of fizzled or sizzled instead of fizzled, or whatever they were saying. It was built up in a big way, but actually what goes missed by a lot of people, and certainly the news media, is there are usually fabulous comets out there to look at. And both Pan-STARRS and Lovejoy are still looking absolutely fabulous at the moment.
They are beautiful. Once every 50 to 20 years, we get what astronomers call a great comet. That adjective sounds like, hey, it's swell, it's great. But that's the actual technical term.
Yeah, it is. Yeah.
And that's the kind of comet that is bright enough to be even seen through the light-polluted skies in cities and urban areas. Well, that's not what we get every year, of course. But thanks to the Slooh telescopes, we do see very, very nice comets. And Pan-STARRS and Lovejoy has given us what that nauseating comet failed to give us, and it is an honestly spectacular view of a comet. None of them were bright, naked-eye comets, but nonetheless very worthy comets.
So if you're a Slooh member, you just point the telescope to a comet. And if you don't know how, other members and we will show you how. Bob, while we're on the subject of comets, and we did our earlier show tonight with our esteemed guest from the Jet Propulsion Laboratory, NASA's Jet Propulsion Laboratory, Rob Manning, looking at Mars, because Mars is also the closest it's been to Earth in the last 6 years. Later on this year, we have got a wonderful spectacle on the 19th of October, 2014. Comet C 2013 A1 Siding Spring is making an incredibly close pass to Mars, isn't it?
Yes, imagine that. We're going to have planet Mars, of course not looking as close as it is these days because it would be much farther away, and then this comet coming very close to it. This is a rare event, and I'm looking forward to that myself.
And I believe what NASA are planning is they're going to be pointing quite a few of the cameras that are both in the Mars orbiters and on the rovers up at this comet. I mean, I think I've forgotten just how close it is, but it's making an incredibly close pass to Mars. I think within the distance where Mars's gravity can affect it, but we will obviously be covering that live on Slooh. But Slooh members are already monitoring Comet C 2013 A1 Siding Spring. Bob, we got a couple more questions.
Okay, this is a year for freaky, unusual astronomical events. That's for sure.
We love that at Slooh. We've already done several near-Earth asteroids making their Earth-grazing approaches to Earth, and don't forget we were invited by NASA last year in recognition of all the work we've been doing to actually publicize the cause and trying to highlight the risk and the lack of work being done to monitor near-Earth asteroids and the risk of near-Earth asteroids. So we were invited to participate in NASA's Asteroid Grand Challenge, which is pretty good. But we are going to answer some of your questions now. If you've got a question, all you've got to do is use the hashtag Slooh, SLOOH, and we will do our best to answer them. Bob, how long? This is it's a really difficult one for me to pronounce. Itzalavina says, how long will the moon stay red?
Well, the reddest part of the eclipse, the total part of the eclipse, now only has about 28 minutes left. But then as we get into the part phases in reverse, we'll still see red for a while. But then as it goes on, red will retreat, and our eyes, if we're watching it directly, or the Slooh equipment will increasingly show the shadow as being black. So we don't have that much longer for this beautiful red part of the eclipse. I hope those who are watching both with Slooh and out your window, if you have clear skies, are enjoying that blue star next to the moon, because we have really a nice contrast. The brightest star in Virgo, its name is Spica, and if you're one of those that like to put down astrology or tell astrologers that, hey, come on, you're not following the real universe here, well, this is a good night for it, because if you look at an astrological ephemeris, it will tell you that the eclipse moon is right now constellation of Leo. But if you look up into the sky, there's the eclipse moon right next to Virgo's brightest star. So there you have it.
Right, Bob, we have got on the screen right now a fabulous image. This is Times Square. This is from the eclipse, I think it was in 2010, December 2010. And this is one that I covered actually from Cyprus. I went to Cyprus, and we had one of our other Slooh members of staff in Dubai. And this is, we don't have these, I don't think, in the UK where I'm speaking from, but this is called the jumbotron in Times Square. And Slooh's image was broadcast live in Times Square. How cool was that?
Yeah, that was very cool, especially because, of course, from time where they don't get much astronomy there. I mean, at least you can see the moon in the sky, which I understand in Beijing these days it's quite common not even to be able to see the moon, if you can believe it. That's how bad the pollution is. But Times Square, at least you can see the moon. It was great to have been able to bring astronomy for Slooh to do that to all the crowds at Times Square. Wonderful. I remember that.
It was cool. You are watching Slooh, the Community Observatory. I'm Paul Cox. I'm joined by Bob Berman, who is Slooh's astronomer. Bob is a professional astronomer. He's also an astronomy author. And that's why we're firing our questions over to Bob. Bob, Alicia says, does the moon rotate? Now, this is a really common misconception because we talk about the dark side of the moon, but there's no such thing, is there, of the dark side of the moon?
Not a permanent dark side, no. Just as Earth has a night side and a day side at any given moment, but fortunately for us, no matter where you live on the Earth, it doesn't stay dark, it doesn't stay light. Earth turns just like that. The moon has a temporary dark side, 2 weeks of night, and the other side has 2 weeks of day, but it does rotate. Its period of rotation is 27.32166 days, exactly, and in that period of time, the moon makes one spin. So why is it that when we look up towards the moon, we see the same pattern of blotchy, what they used to think were seas or oceans on the moon, we now know are areas of solidified lava that flowed billions of years ago on the surface. That blotchy pattern, sometimes called chauvinistically the man in the moon, always stays the same. So it looks as if the moon is not spinning, but for us to see it the same, it means it has to be spinning. Because when you think about it, if we were facing the side with your favorite blotches on it, and the moon then moved to the other side of Earth as it orbits around us, why then 2 weeks later, when the moon was the other side of the orbit, we'd be seeing the other side of the moon. The fact that we only see the same side means that it must rotate in exactly the same period in which it revolves around us. And for those who think, well, that is the most amazing coincidence, well, all the 166 satellites in the solar system rotate in the same period in which they revolve around the parent planet. So it's universal. It just means that the parent planet, in this case Earth, which has 81 times more mass and 81 times more gravity than the moon, has captured its rotation, slowed it down until its spin and its orbit are locked in place. And we have that situation in every other moon of every other planet. So it's the norm.
Now, Bob, while we answer a few more questions, we are watching. This is a time-lapse animation that I put together from the 2010 total lunar eclipse. So this is kind of condensing 4 hours of the total lunar eclipse into just a couple of minutes. So we kind of string all of the images together so you can see kind of condensed in this very short period of time all of those phases. Bob, we've got a question here saying, what's a good telescope to use to see planets at their best opposition?
Well, there's no one telescope that fits all. We talked about that earlier,
yeah.
Paul, about people who buy telescopes and they end up in the attic or stored in the basement because they're fussy to use, they shake, they don't show what people expect to. Every telescope and you'll have mirrors which will need periodic collimation. So there's always something.
Yeah, there's always something.
There's always something. So you can't answer that question with a simple what kind of telescope. I'm biased,
but I would give an alternative.
But I'd say use. Let us do the work at Slooh.
Well, that's not a sales pitch. That is an honest answer, because for a fraction of the cost of even a mediocre telescope, you get a Slooh membership to control the telescopes there, which are all tuned up for you and ready. So, you know, we're not doing it as a sales pitch. Bob and I have seen too many people buy too much expensive and cheap equipment and let it rot in a drawer or a cupboard somewhere. So please think twice before you go out there and buy a telescope, unless you're really serious about it, unless you can get into CCD cameras attached to images. You're not really going to see very much, even of the planets. You know, they appear a lot smaller in a telescope than you think they're going to. And don't be fooled by the magnification figures that they put on the boxes, right? You have to have a very large telescope to be able to magnify at high powers. We've got another question here, Bob. Do the waves get bigger in the ocean when the moon gets blocked, or do the waves stay the same? Now, this is from Joshua Aguilar. So this is maybe not just the waves, but the tide. So when the moon is aligned either at new or at full, like it is tonight, are the tides greater? I think we've lost Bob there for a second, so we'll wait for Bob to come back in. The answer to that is yes. If you look at the tide timetables, there is a little bit of a time lag, but around full moon and around new moon, the tides are higher. So let's have a look. I'm going to tell you who we are while we're waiting for Bob to come back in to the show. This is Slooh. We are the community observatory. We operate observatories in the Canary Islands, and we are just about to reopen our Chile observatory, which means that you can control telescopes to look at anything in the southern hemisphere. And I'll tell you, Slooh members are incredibly excited about this because there are some of the biggest and best objects in the sky to look at, but only visible from the southern hemisphere. And the Chile Observatory is well placed for that. So we're really looking forward to that. Bob, if you come back, just join in. But what you can do is anybody can control the telescope. So what you do is you log in from the comfort of your own home. You can sit on your sofa, any old internet connection, doesn't matter, doesn't have to be big or anything like that. And you book a time. You look down the schedule, and the schedule isn't normally booked for longer than one night. There's normally a spare slots the following night and definitely the next night. You choose the slot. You then choose what object you want to image using the telescope. Now, you don't have to know what object's visible because we have a pull-down list. There are several ways that you can do it. You can have a pull-down list, and that will only show you the objects that are best placed and visible at the time you picked. Or if you're an advanced astronomer and you want to set up a coordinate mission to a comet or a near-Earth asteroid or something like that, then you can do that as well. So there's loads of options. We have people doing everything with the Slooh telescopes, from just building beautiful collections of astrophotographs all the way through to people who like to process their own FITS data. I'm not going to talk about that now, but just in case there's anybody out there who wants to know, they can do their own FITS data. Or you can join one of the research programs that we're starting up, and we're looking at near-Earth asteroids, and we're monitoring those, and we measure exactly where they are. We make submissions to what's called the Minor Planet Center, and that helps determine the accurate orbit of these Earth-threatening asteroids. So that's pretty cool. Now, I am delighted to welcome into the show Jeff. Jeff, are you there?
Yes, I am, Paul. Good morning.
Jeff Fox. It's an absolute pleasure to have you on the show. Now, Jeff, you are going to be taking over some of the hosting and some of the production for some of our shows. Where are you based, and what's your background?
I am in California. I'm located in Orange County, the OC. In fact, I've just been outside a few minutes ago looking at the phenomenal moon.
You've got a clear sky.
Beautifully clear skies in Southern California. It's just amazing this morning. But my background is I'm a meteorologist. I know just enough about astronomy to be dangerous. Maybe some of you remember me. I hosted for 4 seasons Inside Space on Sci-Fi, which was the science fact show on the Science Fiction Channel. As soon as they figured that out, they got rid of us. But for 4 seasons, we had a great run. And one of the things that I'm here to do is try and represent those folks who are just getting involved and give them a better idea of how to operate Slooh, what Slooh can do, what you can see, because so much of what can be done with this telescope are things that can't be done in an instant, because you can take a look and take a long duration exposure.
That's right.
To be able to capture more photons on the CCD, to be able to see things that are exceptionally dim. Part of the way you do that, most people think of a telescope, you set up something in your backyard and forget about the fact that the Earth is rotating. So in order to counteract that, you have to have your telescope in motion to counteract the Earth. If you don't do that, things within your scope are going to move out of your view very, very quickly. Yeah. So
it can get very complicated very quickly, Jeff.
Exactly. So some of what you can do with Slooh is to be able to follow what's going on in the sky, literally follow it with the telescope, so you can keep the scope on it for a long period of time, for minutes at a time. And so you can get a long duration exposure and see things that are exceptionally dim that you couldn't see just to be able to look in the eyepiece live. So it's a very exciting thing. And really, with Slooh, we can bring a lot of very sophisticated observing into people who are not able to spend or to locate where a telescope would have to be located. And also, part of what I'm doing, Paul, will be to sort of represent people to folks like you and to Bob, and to get some of the questions that maybe they have for you, the experts, to answer. I mean, for instance, one of the things that we talk about in astronomy all the time is looking at planets when they're in opposition. Well, really, isn't this just the same? The moon and the Earth are in opposition tonight?
Absolutely. Well, the moon is in opposition to the sun.
Exactly. Yeah. The moon is in opposition.
Yep. Yep. And we see a lot of these relationships with a lot of different objects in the solar system. And usually it means that something's going to be pretty good to have a look at.
But people think about the moon. Now we're talking about the Earth's shadow, and they say, well, once a month, don't we have a new moon? The moon isn't illuminated then. So there is a difference between the moon's lack of direct illumination tonight and what you would see during a new moon.
Absolutely. Absolutely. And, one of the joys of, I think, using telescopes and just generally getting involved with astronomy is you get into the rhythm of understanding these really basic mechanics of the solar system. Now, it's also one of the things that puts a lot of people off getting into astronomy, because astronomy can be an incredibly daunting subject to get into. I can remember when I started out, I thought for years, I want to get a telescope, I want to have a look at the sky. And you know what stopped me, Jeff? I thought, I don't know where anything is. How will I find even a planet? But actually, once you get into it, once you kind of muster up the courage to get into it and immerse yourself, especially if you can go into a community where there are helping hands all around who have all gone through and all remember how daunting it was when they first started off, to hold your hand through all of that stuff, it all starts to make sense. But the other fabulous thing that we find in the Slooh community, and members, we often comment on our forums and stuff like that we chat on, is every single day we learn something new. Not even learn something new, but I often make a comment. I've been watching Slooh live for 10 years now, but tonight, bang, that's a brand new galaxy. I've never seen it. One of the members, it's usually somebody like Maynard, who gets these obscure, beautiful galaxies. So suddenly you're not doing it on your own. It's not so daunting. You're doing it with some pals. You can always find people with the shared interest. It doesn't matter what it is, whether it's a variable star, whether it's the moon, Jupiter, galaxies. searching for near-Earth asteroids, or searching for comets or supernovae. There's always a whole bunch of other people around who also have the same interest. So, Jeff, that's what you're joining when you come into the Slooh community. So it's really great to have you in, and your motivation for joining us is spot on, absolutely spot on.
I'm very excited, and let me tell you, one of the things that Slooh brings is something that would help someone like me. Even if I would put out a beautiful telescope in my backyard, I suffer from what so many people suffer from. There's too much light here. So the sky is always tempered. You know, you can only see the brighter stars because there's so much illumination down near the ground. Now, if you use the Slooh telescope in the Canary Islands, or the telescope that we have coming back online from Chile, you're away from those lights. You're away from the extraneous problems that are going to affect the atmosphere.
Yeah, we got a little bit of a light pollution problem down in Chile, but the Canary Islands is an interesting one from the position of light pollution, Jeff, because the Canary Islands are one of the only parts of the world that actually has a light law. And there is a law that forbids people using certain types of lights outside their houses or street lights or anything like that. And it cannot affect the telescope observations. And even they prohibit aircraft flying over the two islands that have the observatories on, our one, which is Tenerife, and the neighboring island of La Palma, where the other observatory site is. So they don't even allow aircraft to fly over.
But very astronomy friendly.
Absolutely. And, you know, actually, well, as a meteorologist, I often try and explain to people why these island chains are really a good position to have an astronomical observatory in. So here we are, we've got an island chain, they're very tall, they're very high altitude, but they're in the middle of the ocean. What is it from a meteorological point of view that makes that the ideal site? Why do you find astronomical observatories there and in Hawaii, which is an exactly similar situation?
Well, first of all, they're up very, very high. So they're up above most of the, or not most of the atmosphere, but a significant portion of the atmosphere. And that means there's less particulate matter there. There's also less particulate matter because you're not downstream from any kind of smokestacks or anything that's going to add pollution to the air. So you're in a more clean location. You're up very, very high. And obviously, in a place like the Canary Islands, you're much less affected by the ambient light down along the ground, which is going to cause problems in most populated areas.
Yep. And there's something in the Canary Islands which means that the observatory site is above what they call the inversion layer. Now, my understanding of that, Jeff, but you're going to tell us because you're the meteorologist.
I will tell you.
It traps the bad stuff down below, doesn't it?
Sure. Here's what happens. Think of the atmosphere like you think of water, like you think of the ocean. With the atmosphere, we normally have temperatures that fall as you go up. So, for instance, I flew today from Milwaukee, Wisconsin to Phoenix, and then from Phoenix down here to Southern California. Well, we were up at 31,000 feet. The temperature outside the plane was somewhere in the 50 to 60 degree below zero range. So you expect it to get colder as you get higher. But what sometimes happens is there is an area in the atmosphere where as you go up in altitude, all of a sudden you reach a warmer layer. This is that inversion layer you're talking about. So as things lift up through the atmosphere, this inversion layer where all of a sudden they see warmer air, then they stop. So what happens is you have air rise but stop below these the level of the observatory. And in fact, oftentimes when you look down, for instance, from all the great observatories in Hawaii, if you've ever seen a wide shot, a regular camera shot, not a telescope shot, you often look down and see undercast. But you're looking down at the clouds. They form only so high, and they stop when they hit the inversion. That's the end of the vertical development. So
that's important. Yeah, in the Canary Islands, and I often say, I mean, I love when I mean, the Slooh Observatory is unmanned. It's fully robotic, but every once in a while something breaks. I have to get out there. We upgrade something or other, and I always say, Jeff, that the view from my office has to be the best in the world. And there's something about being up at that high altitude, or up at 8,000 feet, and we're looking down on the top of the clouds, and you look off in the distance because it's a volcanic island chain. You see the other islands popping up above those clouds, and it's just fabulous. But what you're looking down on is all of that mucky, horrible, turbulent air which is trapped down below you, and that's exactly what you want to be above for telescopes. And that's why we call the Canary Islands Observatory a world-class observatory site. There are 3 sites in the world which are this good, and one's in Chile, one's in Hawaii, and one's in the Canary Islands. And the Canary Islands houses some of the biggest of Europe's telescopes. It actually has a 10-meter telescope, which is absolutely enormous. It also has some of the biggest and best solar telescopes as well. I've got a question for you here, Jeff. You might be able to answer. This is from Yasmin Garcia, and she says, does the weather affect how red the moon appears? Now, is that one for you to answer?
The weather, well, the weather doesn't, but interestingly enough, we would not see the moon look red if the Earth didn't have an atmosphere, because what you're seeing is the sunlight going through the Earth's atmosphere. And as Bob mentioned earlier, it is the light that we see in sunrises and sunsets that then passes through the atmosphere. Most of the colors, when sunlight takes a long trip through the atmosphere, most of the colors are scattered out, and the reds are what's left. So what you're looking at now is the moon illuminated with this light from the sun that has been bent and passed through the Earth's atmosphere. And that's why on a night like tonight with a lunar eclipse, you're looking at this reddish color on the moon. If the Earth had no atmosphere, we wouldn't see that. In fact, if you see a shadow on the moon, the shadow on the moon is very hard. You're either all in sunlight or all in darkness, whereas a shadow on the Earth, because of our atmosphere, is much more soft. It's much more filtered and scattered by the atmosphere. So we don't have the same kind of hard shadow here on the Earth that you would see if you were looking at a shadow cast on the International Space Station or cast on the surface of moon where there is no atmosphere.
Great answer, Jeff. Great answer. We're watching a live image now. This is from the Prescoll Observatory. Matt Francis, the director there, has been providing these stunning images for all of us who either...
And so, Paul, I'm back here.
Oh, you're back, Bob. Well, that's great timing. I was just saying, we're just about 10 minutes away now from what is called U3. This is where the moon is coming out of the umbra, this darker shadow. And we can actually see the effect of that quite a lot. Bob, I'm going to come straight to you with a couple of questions because it's a really nice question. I can remember you answering this on one of our solar eclipse programs last year. What happens more often, solar eclipses or lunar eclipses?
Well,
that's from Zara A, by the way. Sorry.
Oh, yes. Believe it or not, solar eclipses are actually a bit more frequent than lunar eclipses.
And that really surprised me.
Yes, it is. But in terms of being visible, lunar eclipses are far more readily seen. As you pointed out earlier tonight, Paul, when an eclipse happens like this one,
half the Earth can see it. And actually, if you include those areas that only catch the beginning or the end of it, more than half of the Earth can see it when it happens. Whereas a total solar eclipse, as we well know, the moon's shadow has tapered to just a very narrow, perhaps 140-mile band, a little ribbon, a little path along Earth's surface. So only the tiniest fraction of humanity gets to see it.
More people see a lunar eclipse. So it's kind of common thinking. If you ask anybody, they are far more likely to say, well, I've seen a lunar eclipse, than somebody who's not. So that's why so many of us, including myself, assumed that lunar eclipses were actually more common. So Zara, there is your answer. I'm going to answer the second part of that. And that was, do other planets have eclipses? And they do, but there's also, I've got to bring it back to this. Everybody knows my favorite object, Jupiter. And very recently, over the last couple of weeks, Slooh members have been watching Jupiter's Galilean moons as they disappear into eclipse. They fall in. We've got a fantastic image coming up just now. This is one that one of the Slooh members took. And it's when one of the moons passes behind the planet. It's called an occultation. The moon is occulted by Jupiter. But sometimes, even when it's come out from behind the planet disk, you still can't see it because it's in the shadow. In other words, it's been eclipsed. Just like our moon is eclipsed by Earth's shadow, then the Galilean moons on Jupiter are eclipsed by the mighty gas giant shadow. And just imagine the kind of view that you'd get if you were on that moon as you came out of eclipse. It would be absolutely stunning. Oh, I'd give anything for that, Bob. Now, Bob, Matt has been giving us some superb images, and one that I saw earlier, I believe, if anybody spotted it and wondered what it was, it's a wider field view. And I believe we saw the star Spica, didn't we?
Oh, yes. Yes, we saw the star Spica. And I'm telling Matt right now that people have appreciated that. So when you can get that in the field of view, that's absolutely wonderful. I think we have that coming up for you right now.
Yep. So
one of the bluest, one of the bluest stars in all the sky. Spica is one of the very hottest, bluest stars.
For those who are watching with their naked eye, that is the bright object just to the right, if you will, of the moon tonight, to the right and just a little bit below.
Yes, and in our image, there it is.
There it is.
There it is. So if you're, it's probably, I would say, what's that, Bob? 4 or 5 lunar distances away?
Yes, perhaps that, perhaps not even quite, but yes, just about that. Quite nice.
When you see that star, Bob, you've been saying that it's blue. Why is a star blue? Why are stars different colors?
Well, just as the temperature really determines it. It's a whole string of things. The more massive a star is, the more pressure it'll have in its core, and the more pressure in the core, the hotter it will burn. So these are hotter, and it's very similar to if you heat up a piece of metal on Earth. When it starts glowing, it'll glow a dull red, and then a bright red, and if it gets hotter still, it'll turn orange, then yellow. And hotter still, unless it has melted already, it will turn white. Notice it's not green. Glowing metal will never turn green, just as there are no green stars. And if the metal had not melted first, it will have melted by then. But if it hadn't melted, it would turn blue. So blue is the very hottest temperature.
Bob, does this give us some sort of idea of where in its life this star is?
Yes, quite so, except that blue stars die in their youth. They never live to be old. So whenever we see a blue star like Spica next to the moon, it means automatically it's a young star.
And by young, what do you mean?
Typically millions of years, tens of millions of years, rather than
the billions.
Exactly.
Bob, I have got a question which is right up your street. We cover a lot of moons here, don't we? We have a harvest moon. We have a blue moon. We have a giant moon. In fact, I think we've got the biggest moon of the year coming up, super moon. And this question is from Little Leader, and just commenting, saying the red is because the atmosphere and the scattered light. So that's answering one of the questions that somebody else posted. But she's also asking, is the blue moon also because of the same thing? Are blue moons even blue? Now, this one isn't really because of the color change, is it?
No, it isn't. Actually, you can have a blue moon, I've read, never seen one, due to some kind of odd chemical pollution, the kind that we hope we never see. In other words,
maybe you have to go to
very,
China for such things.
Something that's very unusual can perhaps turn the moon looking blue. But of course, what we mean by a blue, the official definition is the second full moon within a single calendar month, which happens every 2.5 years on average. So it's not really that rare.
So, and that happens because a lunar month is shorter than a calendar month. That's correct?
That's right. The period of phases, or the synodic month of the moon, is 29.5 days. And as we all know, every month except for February is longer than that. So you don't have to wait too long before you'll get 2 full moons in a month. In fact, if there's a full moon on the first of the month, unless it's February, you'll certainly have a blue moon that month. And on some months, even if it's the second of the month, you'll get one.
Bob, we see this from... I'm sorry. Bob,
no,
we see this from the Earth, but let's say that we were lucky enough tonight to be on the surface of the moon looking back. This is actually a solar eclipse on the moon, right?
Oh, yes, quite so. With the Earth appearing 4 times larger than the Sun's disk appears, Sun appears half a degree, and the Earth appears 2 full degrees in width. So, with the Earth fully covering the Sun, quite so.
That was a question from MJ, so thank you very much. If anybody else wants to ask us some questions, all you've got to do is use the hashtag Slooh, Slooh. Now, you are watching Slooh, the Community Observatory. I'm Paul Cox. I'm talking to you from England, where it's 9:30 in the morning. If you've made it this late, you've either stayed up very late or got up very early. Either way, we welcome you. And we are still watching this total lunar eclipse of the sun, of the moon. I'm sorry, it's very late. I told you, I haven't been to bed yet. So this total lunar eclipse, we are 3 hours into it now. And we are just seeing it emerge out of that umbral phase. So it's starting to lose its color again, but we're going to stay with you until the end. We've still got a fantastic interview with Duncan Copp, who is a filmmaker and documentary maker, and Bob spoke to him the other day. So we're looking forward to that, but you can ask us questions. Now, don't forget, we've told you a couple of times, but you can use the Slooh telescopes to point them wherever you want. These are fantastic telescopes at a world-class observatory site. All you've got to do is join Slooh. And the community around it is absolutely fantastic. There's lots of helping hands. It's a really supportive community. So if you're a little bit daunted by the subject of astronomy, don't be, because you'll have all the help you can deal with. But if you sign up and join up to Slooh today, you will receive this fabulous pair of free binoculars. These are not cheap binoculars. These will cost you $90 if you go out and buy them. Now, this offer is, unfortunately, we can only ship to the US. So if you're outside the US, you can still join up as long as you can give us a USA shipping address. So if you've got some mates over in the USA, they can take delivery of them and they could ship them out to you. These are large binoculars. These are what are called 12 by 70, which means 70 millimeters is the size of the objective lens, and that's the lens at the front. 12, that's basically 12 times magnification. These ones give you a field of view of about 4.6 degrees. Bob will remind us exactly what we can see in that field of view.
Actually, these binoculars are 2 3-inch telescopes, essentially.
They are, yeah. Bob, I know what I meant to ask you, because a lot of people don't know how to use a pair of binoculars properly. Now, a lot of people, their vision in each eye is slightly different, and good binoculars like these have what's called, is it a diopter? Is that what it's called?
Yes, you custom do it for your own eyes. First, you look through the binoculars with the left eye, and using the and then focus on the object using the central focusing knob. And then when that's nice and focused, then there's a separate individual adjustment on the right eye,
on the eyepiece,
on the eyepiece itself. So that lets you bring the second focus into keeping with the first. There's also an interpupillary adjustment where you can make the eyepieces further apart or closer together to match the distance between your eyes. So once you've done that, you need do nothing else. Then it'll be just fine for your eyes, especially if you're using it for astronomical use. You've already focused it to infinity, and the truth is you just have to grab it next time and do nothing.
Yeah, and the other very important thing that people don't do with their binoculars is they are hinged in the middle. You really need to move both of the eyepieces in and out. So you're holding the binocular, and you need to get the spacing between the eyepieces just set right for your eyes, and you'll know when that is, because the view will become a lot more comfortable. Now, we are being joined today by Bob Berman. He is Slooh's astronomer. Bob is a professional astronomer. He's an astronomy author. He is at the observatory called the Prescoll Observatory with director Matt Francis. And Matt is the guy who's beavering away in the background. And I cannot explain to you just how much pressure it is, generating these live images for a live show, especially a show that's lasted 4 hours. So, Matt, I know you can hear me there in the background. Fabulous work as ever. We really are appreciating your efforts. But we are also joined this evening by Jeff Fox. Now, he's an ex-weatherman. He is joining Slooh to take over some hosting duties and some production duties. Now, Jeff, we're going to say goodbye to you very shortly. Because we're going to be showing an interview with Duncan Copp that Bob did. But have you got any last words for viewers tonight?
No, I just want to say that this is a phenomenal event tonight, and certainly part of what I'm going to be doing is putting together some videos to help people understand more of what they can do with this incredible community telescope that Slooh has in the Canary Islands, show you a little bit more. I have seen some of the observations that our community members have taken of comets and asteroids. This is the kind of observation that this telescope is just made for. And so many of the observations, so many of the really good observations and discoveries of asteroids and comets have actually come from amateurs. So this is the kind of equipment that can be used to do this. And I'm pretty excited. No, I'm very excited.
You're right to be excited, Jeff. I mean, people always hear how excited I get about this stuff. And I've been doing this for 10 years. But frankly, watching people use the telescopes for the first time to collect their first image of the great red spot on Jupiter, or to grab that first image of the supernova that exploded in the Whirlpool galaxy, let alone some of the first. We had a first last week when Slooh members of the Slooh Research Group who monitor near-Earth asteroids were the first people to confirm the position of a newly discovered asteroid. That is so ultra cool.
And for so many people, it's just impossible to get your hands on equipment that can do this in a location that's conducive to being able to look with low light pollution, with low pollution, and to be able to see deep, to take these long exposures that are often necessary, where the planetary drive within the telescope will keep you right on point. These are things that are very, very sophisticated and not always available to amateurs.
No, and we pride ourselves in doing that. And the community, I think what you'll find very quickly, Jeff, the community aspect of Slooh is one of the strongest parts. Now, it's been an absolute delight to introduce you this evening to that community, but also to our wider audience tonight. So thank you very much for joining us tonight. And we're going to be seeing you very soon, I hope.
Yes, absolutely. Thank you. And I'm going to now, when I get off with you, I'm going to walk outside and take one more look at the beautiful moon under our clear California skies tonight.
Take care, Jeff. Thank you very much for joining us. Good night.
Bye-bye.
Now you are back with us. Here we are, Slooh Community Observatory. We are watching the live lunar eclipse. This is a total lunar eclipse. It's visible in North America and South America. We just caught the end of it, if you remember, from the Canary Islands Observatory, where the moon was setting just as the shadow of Mount Teide, the volcano, pointed down towards the moon. Now we are starting to see this marked change in the eclipse. Bob, This is that last image suddenly clicked, and there we are. We're kind of very obviously out of the total lunar phase, aren't we?
Yes, we're back to the time of maximum strangeness again, the TOMS. This is the time when people who didn't know what was going on could not figure it out. If you looked at the moon, just took a quick a half moon. It could fool somebody into thinking that it was just an ordinary moon on a non-eclipse night. So enjoy this period of time now. Also enjoy it because the distinct redness, it was so beautiful, that coppery, deep orangey color that we still see is going to now fade and be replaced by the appearance of a black shadow. We now know that it's really a red shadow. But as the exposure must change to compensate for the brilliant sunlight that will be increasingly striking the moon's surface, we will have to underexpose the red part, and that will appear black. And the same is true if you're watching it directly. Your eye will underexpose the red part and start to make it appear black. So we're going to say goodbye to the colorful part of the eclipse very soon.
But we're going to remain with you for the entire eclipse. You're not getting rid of us that quickly. Now, Bob, one of the things which we've talked about on previous eclipses, and I know it's a topic that you're incredibly well versed in. What did our ancestors think? There's a lot of what's called moon lore out there, isn't it? What would they have thought when the moon turned this peachy, coppery color when they saw it?
Well, you're very kind to say that I'm very well versed in it, but I'm really not. I don't think any of us know what they thought, especially in prehistory, before we have written records. We do know that there was not a belief in Earth moving through space. Earth was thought to be stationary. It says so in the Bible. In fact, the main point is that Earth cannot move. And the moon, however, was thought to be one of everything in the universe that revolves around us. Now, why it should undergo changes was greeted by ancient and primitive peoples alike with distrust and suspicion. Change was not good. The heavens were considered fixed, part of the divinity, and any alterations, for example, comets in the sky, were invariably regarded as omens of evil.
Except Attila the Hun, who saw a comet as being good, a good omen for him, didn't he?
I've seen that, but when you're evil yourself, maybe more evil looks good to you. Yes, that's
absolutely.
Right.
I hadn't thought of that, Bob. So, Bob, we are going to switch to the discussion that you had with Duncan the other day. Now, before we do that, our producers are getting that up and ready for us. I just want to ask you about something you said a little bit earlier on the show about us always knowing about the moon orbiting the Earth. It's really only a few hundred years, isn't it, that we've really fully understood the mechanics of the solar system, and really understanding and not only understanding but accepting that actually the sun is at the center of our solar system.
That's right, and people think that it was Copernicus and Galileo who subscribed to the popular magazine at that time was Heliocentrism Today. That they all had subscriptions to that, they subscribed to that. But it was really Aristarchus of Samos, we're talking about several hundred years BC, who alone, and 18 centuries ahead of everybody else, said that it makes just as much sense, more sense, for Earth to be moving and going around the sun, because he was one of the first to calculate that the sun was larger than Earth. It made more sense for him, for the smaller body of Earth, to go around the larger one of the sun than for the sun to go around Earth. And he said, as for the appearance that the sun rises and crosses the sky and sets, he said, you would get that same appearance if Earth were spinning.
Yeah.
Then it
look as if the sun were rising up and down. So he told everybody who would listen that Earth spins on its axis while it goes around the sun. And all the other Greeks, including Aristotle, whose so-called wisdom was spreading far and wide at that time, and everyone was believing Aristotle that the Earth was the immobile, immovable, the stationary center of the universe, and everything else went around. So we have to salute Aristarchus, who alone was way ahead of Galileo and Copernicus and all the others in pointing this out.
Absolutely. Well, just before I let you introduce your discussion with Duncan Copp, documentary filmmaker and Slooh friend, I just want to remind people you are watching Slooh, the Community Observatory. And when we say Community Observatory, we really mean it. It's a fabulous community. Now, if you join Slooh to use the robotic telescopes, Jeff, I got to remind Jeff actually that Slooh doesn't have one telescope. It has 3 telescopes at the Canary Islands Observatory and 2 telescopes in Chile, including the half-meter telescope in the Canary Islands, an absolutely astonishing telescope that you'd have to be pretty wealthy to be able to afford yourself. Those are the telescopes that any Slooh member can control. And I'll tell you, joining up to use those telescopes costs a lot less than even the cheapy telescope that you can buy down at the local store. But more than that, today, if you join up over the next 18 hours, we will give you a fabulous pair of binoculars. These are not cheap. They'd cost you $90. So they really are. We've talked about them earlier. If you've missed us talking about them, then you can go back, have a look at the recorded show, and we'll tell you all about the binoculars and how to use them. So, Bob,
and you know what we're doing now? Matt is sending you now something we have not done during the program. That is a view through the main telescope, or one of the large telescopes here in the dome, of the moon blown up. And looking at the shadow line now, the exact place where Earth's shadow is meeting the part of the moon that has light on it. And if you wish to share that with our viewers, you know, we have both feeds coming out now. And just for a little variety, you want to see the shadow line of Earth. He's sending them out at the moment.
Absolutely. So while our producer cues that up, Bob, why don't you tell us about this interview? Duncan Copp, he's a British filmmaker, documentary maker. He made In the Shadow of the Moon, a documentary about the moon, interviewing just about every living astronaut there was. It's an absolutely fabulous program. Highly recommend you getting that to watch it. Won a whole stack of awards. But Bob, you spoke to Duncan the other day, and we recorded this interview. What did you guys talk about?
Well, rather than spill the beans, Duncan really we sort of went off on a little bit of a tangent. Of course, it was the moon as well, but you know, he's a very, very interesting fellow, as you know. And we thought it would be a lot of fun to share his mind with our viewers and listeners, especially as we get to the wee hours of the morning in almost the entire Slooh viewing area while we're seeing this eclipse, and as the sunlight returns to the moon during a very successful event. So I'm actually looking forward to hearing it now a second time after we did this.
Okay, well, that is what we are going to switch to. We're going to be waiting for our producer to cut that over. But listen, you have to come back. Bob, how long does the recorded segment last with Duncan?
As I recall, it was something in the area of 17, 18 minutes.
Okay, so you have to join us back, because we will continue with live images of this total lunar eclipse. We're going to be with you until the end. And if you've got any questions, then line them up for us. Just use the hashtag Slooh, and we will endeavor to answer all of your questions when we come back after this recorded interview that Bob did with Duncan Copp, film producer.
Welcome back to Slooh's coverage of the 2014 total lunar eclipse. I'm Bob Berman, And joining us now is Duncan Copp, the award-winning documentary filmmaker. Duncan created In the Shadow of the Moon. That was just an amazing film about the Apollo astronauts and our trips to the moon. And, hey, our focus is on the moon right now, so I'm just really pleased to have Duncan here from London. Good evening, Duncan.
Good evening, Bob.
And, of course, the world's attention right now is on the full moon as it sits within Earth's shadow. And when an event like this happens, what does it conjure up for you?
Oh, I think it's always exciting. You know, it's one of the joys about astronomy. There's always something that's going on. And I remember, this is going back a few years now, but when I first saw my very first lunar eclipse, which was probably back in about the 80s now. And it's just that wonderful, wonderful spectacle of seeing the moon slowly disappear, as if it's a little edge of it's being bitten out. And it's dark. But then when you enter totality, the moon suddenly takes on this beautiful bronzy orange copper color, a bit like a carrot. And it's beautiful to see that. So it's always exciting to watch lunar eclipses.
Yes, quite so. I remember in my early years it puzzled me as well. Why is the Earth's shadow seemingly black at first? And then as we approach totality and get into the total part, is our shadow its true reddish color? And then finally it dawned on me one day that it just has to do with our human eyes' adaptation to the light. When the moon is still very bright, the shadow is very dark by comparison, and so it looks black. But as our eyes adjust to the diminishing light, we get to see the true red color. It's fascinating. So if we had to rate the events that involve Earth and the sun and the moon, the most famous perhaps is a total solar eclipse when the moon blocks out the sun. So for our viewers, people who are joining us here tonight, just to be clear about the difference between them, in tonight's event, the Earth's shadow is blocking out the moon. The moon isn't actually blocking out anything else. It's going into Earth's shadow. How would you compare the two in terms of impact, visual impact, or scientific information, or in any other way, the two main types of eclipses, Duncan?
That's a great question, actually, Bob. I've only witnessed one total solar eclipse, and that was in August in 1999, when totality, the shadow of the moon, just clipped the United Kingdom here, and we were in the Channel Islands watching, and typical British weather, a little bit touch and go, a lot of cloud, a lot of high cloud around, but we did manage to see totality, and that was an amazing experience. I mean, something that I would utterly recommend everybody do if they have an opportunity to do so. And an amazing day. I mean, it started off, as I say, quite cloudy, and we all went to the island of Alderney, which is a very small island in the Channel Islands, and it was heaving, absolutely heaving. And, of course, totality came, and everybody wanted to take a photograph either of themselves or the event. And so it was like being at a rock concert, the whole flashes going off everywhere, everybody cheering. And, of course, it was dark. It was unnaturally dark because it was the middle of the day. And you could see the shadow of the moon race across the ocean and come and take the light away, if you like. It was amazing. Lunar eclipses are a lot slower in their progression and last for many hours, so perhaps they're not so dramatic, but they're equally interesting as a spectacle. I think in terms of science, though, I think a total solar eclipse probably wins hands down, because that's the only time when we're able to see the superheated solar corona, this very, very wispy, thin, gaseous corona that surrounds our sun, almost like a gaseous atmosphere. And you can only see that when the very, very bright surface of the sun is blocked out. And that's really that beautiful wispy effect that you're seeing surrounding the moon, which is in front of our sun during a total solar eclipse. And that's very important to study, because I think I'm right in saying that the the understanding of why the corona is so hot. It's something like 2 million degrees compared to the surface of the sun, which is about 6,000 degrees. Still very hot, but the mechanism by which that solar corona is heated is still not fully understood, and I think it's one of the holy grails for solar physicists, and that's why they want to study the solar corona, and of course a total solar eclipse gives them a very precious opportunity to do so.
Yes. Now, on the lunar eclipse that we're watching tonight, we have something that's remarkably different and also similar in a way. For example, if one were on the moon right now, one would see the Earth gliding in front of the sun. Now, the Earth appears 4 times larger in angular size than the sun does, as seen from the moon. So the Earth easily covers up the entire sun, and yet, during the time of totality, the Earth being lit up from behind by the sun. You have to picture this. Will look, of course, pitch black, and then surrounding the Earth will be a ring of fire, a fiery atmosphere. All of the world's sunrises and sunsets combined into a halo, and it's this light that hits the moon during the total part of the eclipse. So we almost have an analogy, don't we, Duncan, where during a solar eclipse we see the moon surrounded by the glowing atmosphere of the sun, and right now if you were on the moon you would see the Earth surrounded by its own glowing atmosphere, lit up from behind by the sun. So fascinating events. Your documentary on the moon and the Apollo astronauts, well, ever since it was made, the plans to return to the moon have kind of retreated, haven't they?
To a degree, I think so, and I think, you know, in some respects, some of the major spacefarers now have turned their attention to other bodies in the solar system. But I think there's always an interest in the moon. I mean, it's our own natural satellite. It's the closest celestial object to us, and to some degree, it still remains a bit of a mystery, and there's still a lot to explore there. And after the Apollo astronauts left, the last Apollo mission was Apollo 17 in December 1972. No humans have been back to the moon, but of course there's been a whole flotilla of unmanned missions. And in particular, NASA have launched some missions, and the European Space Agency, that have really mapped the moon in very high resolution, very high detail. And that's giving a really interesting insight into the kinds of chemicals and minerals and possible resources that exist there. So
yes, and of course, when you say possible resources, probably since the final astronauts were there, as you just mentioned, in December of '72, probably the most striking finding, wouldn't you say, is first the U.S. Army's Clementine mission, and then subsequent confirmation that there is probably ice on the moon. What do you think of that?
Extraordinary and very exciting, and yeah, Clementine was a very exciting mission. In fact, when I was doing my research, that mission was underway, and I had a colleague of mine who was using the Clementine data. He was looking at the moon. So this idea about ice on the moon may seem a little incongruous, a little surprising, but what we understand now is there are certain craters towards the poles of the moon that are in perpetual darkness. They never see sunlight whatsoever. And you only have to look at the moon to understand that it's been bombarded by impacts over billions of years. Some of them are asteroids, but some of them are comets. And comets, you can sort of think of water buckets of the solar system. They carry water and they deliver water. And what's thought to have happened is that water's being delivered to the moon when the comet has struck it, and it's formed a very thin atmosphere. And some of that atmosphere has made its way up to the poles and has basically been encased and trapped now underneath the lunar surface, underneath the lunar soil, which we call the regolith. So that's where that ice is residing. And because there's no sunlight up there, there's nothing to disturb it. There's nothing to melt it.
And having ice on the moon means what for the future?
Well, I think that's very exciting, because if you think about our own daily lives, we totally depend on water. I mean, water to drink, water to make fuel. You can separate water and make energy. So, you know, if there were plans to return to the moon, and if perhaps we did want to colonize that body, we would need a ready supply of water, and it's going to be far too expensive to bring that water from Earth. So I think that's why it's very exciting and perhaps opens up a whole new phase of exploration if and when we decide to go back to the moon.
For those who are just joining us, I'm Bob Berman for Slooh. Our guest during this segment is Dr. Duncan Copp, an award-winning documentary filmmaker who made In the Shadow of the Moon about the Apollo missions to the moon, interviewed many of the astronauts, had them on camera. But I also want to mention that, that Duncan Copp has a PhD in planetary geology. His specialty is Venus. But when we're talking about the moon, because he spends so much time presenting the moon to the public, he's arguably the best person we can have for this show, while the world's attention is focused on this fantastic total lunar eclipse. So let me ask you, Duncan, as we now look at the moon, from what you've just said, most of the moon that we're looking at is bone dry, but up at the top and down at the bottom in permanently dark craters that never see the sunlight, we have now confirmed the existence of ice that can be used both, of course, to be melted and used for the water that future human lunar colonists could exploit, or disassociated into its component, hydrogen and oxygen, and used for rocket fuel or for energy. So it's a game changer, isn't it?
Yeah, I think it's very exciting, and it's also interesting to know that there are lots of companies here on Earth at the moment who are thinking about returning to the moon. These are private consortiums, private groups, and the discovery of ice up at the polar regions of the moon, I think, is a big incentive and potentially a big help in getting those projects off the ground. Not right away, but in the future. And I think, really, it's only a matter of time before we do decide to go back to the moon.
Okay, let's say we go back and now we've got the water that we need, that we don't have to haul from Earth at 8 pounds per gallon, very expensive and probably prohibitive thing to do. We can go back, we can use the water for rocket fuel, for energy production, but still, why go there? Some are saying that the moon contains the surface contains a kind of helium that might be exploited. Is there anything valuable on the moon, or is it pure science?
Well, again, Bob, that's a great question, and it's a question that I think people ask all the time. Why go to the moon? And I think it's inherent in us as a species to explore. And I think the moon has always been a lure. And if you talk to a lot of the Apollo astronauts, you know, why go to the moon? Well, because it's there. And, you know, why did Lewis and Clark travel across America? I mean, you know, it's almost as if it's the next frontier, and there's an element of humanity that always wants to explore. Now, having said that, obviously we have to get that in context with our priorities and what it is we need to do to make sure that we're building a sustainable future for ourselves here on Earth. But I think space and the development of space, be it low Earth orbit, be it the moon, be it asteroids, is going to become a part of that really quite soon as technology improves and our capabilities get better, and there is a way that we can exploit in a commercial way space for the benefit of everybody. That's, I think, the salient issue here.
Very good. Playing devil's advocate, one would say that we've been to the moon during all those missions from 69 to 72, been there, done that, didn't find anything valuable. Why shouldn't we just turn our attention to other celestial bodies? Why go back to the moon? How would you respond to people who say things like this?
Well, I think it's a very good question, and I think it's a very good topic for debate. I think we mustn't neglect the other objects in the solar system. They're equally valuable. Some of them may be even more valuable, some of the asteroids. But the moon, I think, because it's our nearest neighbour, because we have a degree of familiarity about it, we have been there, but we should use that to our advantage. The fact that we have been there means that we know a little bit, in fact we know quite a lot about its environment and perhaps what we would want to do when we go back there. And if you think about the Apollo missions, you know, there were only 12 men who walked on the surface of the moon, and if you add up all the days that they spent there, you know, it's probably less than 2 weeks actually on the surface. And again, it was only the later missions, Apollos 15, 16 and 17, that took up the lunar rover when they could actually drive a couple of miles. So we only scratched the surface with Apollo. And Apollo, although had some scientific goals, you have to remember that really that was very much a political undertaking, as set by President Kennedy. So, you know, I think taking all those facts into consideration, I still think there's a great deal we can do if we go back to the moon to learn about ourselves, actually, learn about our own planet, and learn about how the solar system itself formed, which, again, gives us a very good insight into how the Earth formed. And fundamentally, that's what we want to know more about.
Thank you. This is Dr. Duncan Copp joining us from London as part of Slooh's ongoing live coverage of the total lunar eclipse. Thank you so much for joining us, Duncan.
Oh, you're welcome, Bob. It's always good to talk to you, and always good to be a part of Slooh. It's just fantastic. And happy lunar watching.
Thank you. And good night for now.
Good night.
Welcome back to Slooh's coverage of the 2014 total lunar eclipse. I'm Bob Berman, and joining us now is Duncan Copp, the award-winning documentary filmmaker. Duncan created In the Shadow of the Moon. That was just an amazing film about the Apollo astronauts and our trips to the moon. And hey, our focus is on the moon right now, so I'm just really pleased to have Duncan here from London. Good evening, Duncan.
Good evening, Bob.
And of course, the world's attention right now is on the full moon as it sits within Earth's shadow.
Hello and welcome back to Slooh, the community observatory, where we are watching the end of the total eclipse of the moon. I hope you enjoyed that segment with Bob Berman and Duncan Copp. I'm Paul Cox. I'm talking to you from England. It's 10 o'clock here in the morning. If you've stayed up this late or you've gone out really early to watch this total lunar eclipse, then thank you very much. We've got half an hour. We've got a lot that we want to put in this half an hour. We have got questions about conspiracy theories, plus a whole stack of other questions that we're going to try and answer. But first of all, I'm going to talk to Matt Francis of the Prescoll Observatory. Bob's then going to do a bit of a recap for the whole eclipse. We're then going to show you some fantastic images that Slooh members have taken recently. And then we're going to devote that last bit of the show to your questions. So if you've got any questions that we haven't answered yet, please just use the hashtag Slooh, S-L-O-O-H, and we will endeavor to answer all of your questions by the end of the show. Don't forget, you can join Slooh today and get that free pair of binoculars. So a great incentive, not that you need incentive to use some of the best telescopes at one of the best telescope observatory sites in the world, but there's a little incentive for you there to have this fantastic pair of binoculars. Now, I am delighted we've pulled Matt Francis, director of the Prescoll Observatory, away from his camera and telescope. He's been providing these fabulous live images of the total eclipse of the moon tonight for us. Matt, absolutely sterling effort. I know there's a lot of pressure there. So first of all, thank you from Slooh, and thank you to all of our viewers tonight.
Thank you, Paul. It was a pleasure. And as we were discussing before, it is, for people who don't know what it's like to operate an observatory of this complexity, it doesn't, I can just say it doesn't matter how much you prepare, because something is definitely going to go wrong when you really don't want it to.
Absolutely, especially when you've got tens of thousands of people watching your live images, so the pressure was really on. And I must say, you've come out of it and you're an absolute hero of the night. Now, Matt, tell us, you set up, or you bought the Prescoll Observatory a couple of years ago, I think. What was the aim of you doing this? I mean, you're a young guy, and here you are, you're sharing your observatory with Slooh and our huge worldwide audience. Why are you doing it, and what are you doing?
Yeah, this entire idea evolved from a simple desire to build just a very basic roll-off roof observatory somewhere at a dark sky. I could use my existing equipment, which was a 12-inch Meade telescope, to take some simple photographs. And before I knew it,
you got a bit carried away, didn't you?
Yes, I did. I got very carried away. But that was the thing. I almost feel like it's almost like a Forrest Gump type of a thing, where I just feel like things keep happening to me, and I just keep putting one foot in front of the other. And yeah, before I knew it, this observatory and home cropped up on a real estate website, and I came and looked at it, and the observatory was way overbuilt for what was then happening, which was wide-field imaging of the sky and asteroid detection, which was great. The previous owner did astonishing work, and when he left, he took his equipment, and I began the research on what type of telescope I wanted. And when I started it, my field is nanotechnology, and specifically electron microscopy, and so I've always been interested in cosmology, the relationship between the very small and the very large.
Yeah.
And so I had 3 goals in mind when I started this, and that was public outreach, which thanks to Slooh is happening in a really nice way. It's just so much rewarding to be able to reach, hundreds of people, thousands of people, whatever our shows turn up. I mean, this far exceeds the perhaps 10 people or so at a time I could get in my observatory. So that's been a really, really rewarding thing. And
it's something that I think we're all of us involved with this. It's one of our drivers. It's one of our personal drivers towards this. And Matt, I always say, and I've said it publicly as well, even with our huge audiences, even if we have only achieved to inspire one kid to get into science, technology, or engineering through our shows, then I go away a happy man. But the fact that we do reach such a wide audience, with the help of partners like yourself, with the help of Slooh members who join Slooh, that pay the money to enable us to hold these free public events, it's incredibly motivating and incredibly rewarding to come away from one of these shows knowing that some dad has kept his 2 kids up and they've been watching your images from your observatory, and you've probably inspired those kids to do something, whether or not it's just read a book, or whether or not it is to look through a pair of binoculars, or maybe even follow a career in science, technology, or astronomy. So you're really to be held up as a wonderful example of altruism. So thank you very much for all you do for us.
Well, thank you. I can tell you that I turned down my neighbor's request to go sit in their hot tub and just watch the lunar eclipse from there.
Oh, well, that was painful. Now, listen, Matt, as much as I'd like to talk to you more, get back to your telescope and give us some more live views, please.
I'm doing that right now. I'll hand you over to Bob.
Thank you very much. That was Matt Francis. He is the director of the Prescoll Observatory. He is a wonderful chap. Now, Bob, thank you very much for coming back. Now, just to remind people, we are in the last 25 minutes of this eclipse. You are still watching a live image of this lunar eclipse. But in this last segment, Bob's about to give you a recap of the entire eclipse, what we've seen, why we saw it, why the eclipse occurs, just giving us that little recap at the end of the night. We're going to have a look at a few Slooh images from the members, and just to show you what they take. We're not going to spend a lot of time on that, because the biggest thing we want to do is say an enormous thank you to all of our viewers out there tonight. You've had us trending tonight. We hope we've given you an informative and entertaining and loads of live images, because frankly, me in England, people under the clouds, people around the world would not have seen this lunar eclipse if it hadn't been for these live images that we've been showing. Right. So we're going to have a big thank you to you. And actually, we are going to cover as many questions as we can at the end of the show. So use the hashtag Slooh and we will get those. We've already got a bundle of reminder of what it is we've been watching tonight.
Well, we saw a total eclipse of the moon, but it was the most special one, I would say, of our lives. Sometimes years pass before there's a total solar eclipse visible from the entire United States. In fact, years to pass. And so it was an unusual event. What made it particularly extraordinary is that it happened on the same night that Mars came closest to Earth for the last 6 years, on what we call the near approach of Mars, and therefore Mars was close to the moon in the sky. We saw the eclipse moon, which also happened to be alongside the bluest bright star in all the heavens, Virgo star Spica. So here was the moon going into Earth shadow. Earth casts a red shadow in space, and so the moon turned a beautiful coppery red color when it was fully immersed. We watched it go through a strange series of pseudo phases before the totality that lasted an hour. Then we watched totality persist for more than an hour, and now we're watching it go back into the sunlight. We're going to have an ordinary full moon coming up in only about half an hour as it leaves Earth shadow. We can see the curvature of Earth shadow, proving to any doubters that we really do live on a sphere, on a ball, not on a flat place in space. But we'll never again, for the rest of our lives, see a totally eclipsed moon on the same night that a bright planet came closest to Earth. So, very extraordinary.
Fabulous. And you've been here all the way through, Bob, so thank you very much for all of your work. But your work is not done, because I'm going to put you to task in a minute and put you up against the wall with these questions. The difficult ones, the easy ones, all of them.
My pleasure.
But first of all, let us have a look at some of the Slooh member images. Our producer's going to line those up. Don't forget, you can ask questions that we're going to do now, just using the hashtag Slooh. And Bob and I will answer any questions. You can also pose questions, of course, to Matt Francis as well, director of the Prescoll Observatory, who's been imaging these. Now, let's have a look at this first image. Now, this one, to me, Bob, this is a galaxy. I can't see it very big on my screen, I'm afraid. Do you recognize that one?
Well, I'm going to have to go across the observatory, of course. Here
I'm sorry.
All the motors and the telescopes and the wires. You have no idea how many wires are here in it. And the screen which we are seeing, the Slooh feed, is several feet from me. So it's actually too small for me to even see what you're showing.
It is. Well,
Matt has put it on a different screen, but it's still a little bit too... now he's put on even a larger screen. He's helping us out. The nice thing about the galaxies that we see at Slooh is that in just a few minutes we're bringing out the full color. Now, unlike most of our galaxies, this one looks a uniform color, but usually we see a cobalt blues in the spiral arms and campfire orange color in the core of the galaxy, depending upon, and it shows you where the older stars and where the younger, hotter stars are. The nice thing about these Slooh images is that the members can point the telescope anywhere. Perhaps they've heard of a particular galaxy or a planet, or maybe they hear that somebody talked about Saturn. Well, okay, they can just order the telescope to point to Saturn that night, capture the image just with a click of a button, and then forever have it as their desktop or send it to their friends and be able to say, in all honesty, I took that picture. So,
yeah,
fantastic.
Our producer's going to just quickly nip through a few of the images, example images. Oh, this is one of my favorites. Look at that comet. This is the one that showed the what's called an anti-tail, I believe. That looks like the one. An anti-tail, Bob, is the comet kind of shows another tail that looks like it's coming out of the other direction, doesn't it?
Yeah, going the wrong way, going toward the sun instead of away. And
this was taken by Slooh member Nomal Paul. A stunning image. That's a monochrome. We've got another galaxy coming up. Our producer will show us a quick image of Andromeda as well. Now, strangely, Bob, this image of Andromeda is taken with Slooh's smallest telescope. And you'll explain why our smallest telescope can take an image like that of Andromeda.
Yes, because there's always a optimal magnification for everything. You want the type of power, the type of blowing up of an image that gives you the most beautiful and scientifically useful view. So for some objects, for example, we need quite a bit of magnification to bring it out because it's so tiny. Mars is only 4,000 miles in diameter, and despite it being close, it's just not a large object. But Andromeda takes up as much space in our sky as 8 full moons in a row.
Yeah, I mean, it's massive, a massive object. Yes, and then the next image shows the total opposite end of that. It shows our kind of the equivalent of highest magnification telescope. And this is our planetary telescope, which has a far smaller field of view on it, which means that you really start picking out the detail of Jupiter. You can see one of the members has marked up the 4 Galilean moons, maybe a shadow as well moving across there. So you can see that you can go from the smallest objects in our solar system to imaging nebulae. We've got a nebulae coming up here. Now, this nebula is in our galaxy. But of course, we've just seen a couple of other galaxies, the Andromeda Galaxy and I think the S Galaxy, which are not part of the Milky Way. So all of these objects, and don't forget, all of this stuff is processed in real time. You don't have to do all the processing for this. This is what you see through the telescope. So, Bob, I think we've given people a taster of that. I mean, yes, frankly, yeah. You look at, what's coming in, but don't forget, you can look at everybody's mission. So whatever anybody else is controlling the telescopes to view, you can see it on your screen as well, and you can snap your own image of it. So don't forget, if you want to control those same telescopes, join Slooh in the next 18 hours, something like that. We're going to keep this promotion running just today on Tuesday, and you will get a free pair of binoculars. Just go to slooh.com, press the membership button, and all of the details of that will come up. If you want to know more about those binoculars, we've talked about them earlier on in the show. We're not going to tell you about them now because we want to get on and do some of your questions. So, Bob, the first one we've got is from Dane J. And the question is, would the eclipse look different if the sun was different in size and or brightness?
That's a great question.
Interesting
well, of course,
isn't it?
Yeah, that's an interesting one that I don't think I've ever had before. If the sun were different in brightness, the moon would appear different in brightness. And so, of course, it would look different in that respect. Also, if the sun were different in size, the edge of the Earth's shadow would have a different degree of fuzziness. If you look at the live picture that we're showing you now, you can see that the Earth's shadow does not have a sharp knife edge to it. It has a blurry edge. And that defines where you're going from where there's no sunlight shining on the moon to where there's a tiny bit where the sun is blocked out just 1% of the Earth, and then 2%, 3%, 4%, etc. And all the way on the left side of the moon, the way we're watching it, is where the sun is almost completely now shining fully, and there's only a little bit of Earth blocking out a little piece of the sun. So it's a gradation. Well, if the sun were different sizes in the sky, that gradation would have different dimensions.
Yep.
And so the sharpness of the shadow would change.
That is a great question, Dana. I haven't heard that one either before. Bob, somebody asking, I think it's Tracy Hillard, is asking this one about the binoculars. I have astigmatism and myopia of varying degrees in each eye. Can those binoculars actually allow me to work without my glasses?
No, the
think
answer to that is no. The myopia can be corrected by simply changing the focus of binoculars, but the astigmatism cannot. So if you have serious astigmatism, you'll still have to wear your glasses.
which I
Fortunately,
believe you can do with these binoculars, Bob. Certainly, the write-up says that the eye relief should enable most glasses wearers to still retain their glasses on. So do you see a problem with that?
no, not at all.
No. Okay. So Tracy, have a look at that. But obviously, we'll help you out if we can. There, Izzy Ethier is asking us, Bob, how often in 1 year would you see a blood moon, and how do you know what kind of eclipse it's going to be before it happens?
Okay. Well, the expression blood moon was just created for the eclipse. You see, astronomy writers, I'm one of them, so I know, but
Blame Bob.
there's a certain amount of integrity to it. You want to catch people's attention. You want to say, go out and see the blah blah moon tonight. And so some writers created the idea of this is the blood moon. Well, that's not the name. That is not an official or even an unofficial name for a total lunar eclipse. The name for what happened is a eclipse of the moon. It's not a blood moon. It's just somebody's words for it tonight. And as you saw, we showed you the true color. The moon was more honestly an orange or a coppery color than red color. If your blood looks this color, you really have to get some immediate medical treatment. So it really wasn't a blood moon. So how often does this happen? Well, anytime there's a total eclipse of the moon, normally the normal amount for your location on Earth would be 0. On some years, you'll get 1. It's a rare year indeed that there'll be 2 total eclipses, both seen from where you happen to live in the world. And this is one of those rare years. It only happens a few times a century, and this is one of those years.
And Izzy, the other part of your question about how we know what kind of eclipse is going to be before it happens, well, if you that question was in the context of the color, well, we didn't tonight. We frankly had to wait and see. Next question, Bob. The Wee Rainbow is asking us at #Slooh, will any of the remaining 3 eclipses be visible from the UK?
Oh, that's a good question. The next eclipse, which is an annular eclipse, will not be visible.
Solar eclipse is the
that solar eclipse that will not be visible from the UK. And then, unfortunately, the next lunar eclipse on October 8th will also not be visible from the UK. So, unfortunately, you're gonna bat 0 on this. But stick around, keep eating those health foods, work out in the gym, and next year we'll bring a different story.
But you will be able to see it along with me, because I'm in the UK too, on Slooh, because we'll cover them all except the annular eclipse, which is only visible from Antarctica. We should, though, have coverage of the partial phases from our partners in Australia. So keep your eyes open on the Slooh homepage for our upcoming events. That one's, I believe, Bob, at the end of the month.
Yeah.
Right, our next question is from Curtis Angel. The moon appears very small in North Texas tonight. What makes the moon appear larger and smaller at different times of the year? Well, this is an interesting one because it's a bit of an optical illusion, isn't it?
Yes, and the answer to that is that right now the moon is quite high in the sky from North Texas. Not straight up, but about halfway up the sky, and that will make for a smaller moon. The closer the moon is to the horizon, the larger it will appear, simply because just psychologically, from a lifelong experience of seeing things near the horizon, even if it's a distant town that we happen to see from a rise in the road, from a hilltop, we'll see the little church steeples in the town, and we'll know psychologically that they're not really that tiny, that they're far away. So we psychologically add a little size to them in our minds. Well, the moon is down near the horizon. We do the same thing, and we see it juxtaposed against earthly distant horizon skyline objects, and we give it extra size. When it's higher in the sky, as it is at this moment, it looks smaller. It's dwarfed by the 180 degrees of the heavens. The moon is only half a degree, so it's only 1/360th of the sky, a very tiny little piece of the sky, and it looks it.
Yeah. We are still watching these fabulous live images of the lunar eclipse tonight. This is from the Prescoll Observatory. Bob is there with Prescoll Observatory Director Matt Francis. We are answering as many questions as we can. Bob, how can you tell how far away the stars are if you can't visit them? Do you somehow measure the light?
Well, the easiest way is if at this moment the listener will put his or her finger up in front of, let's say, about a foot in front of your
Everybody
face.
can do this. So do this.
Yes.
Just follow
Yes.
Bob's instructions. So.
Yes, put your hold one finger up, a foot in front of your eyes, and then blink one eye and then the other, and watch what happens to that finger. As you blink one eye and then the other, back and forth, you'll see that finger jumps back and forth and changes positions. This is called triangulation or parallax. Each eye is seeing the finger from a different direction relative to the background. Well, we do that also. As Earth goes around the sun, we have almost 200 million miles between our position in January and our position in July. So if we take a photograph of a relatively nearby star, as how it looks against more distant stars, we'll see it jump position, just the finger jump back and forth, and you can actually produce a triangulation and trigonometrically measure precisely the distance to this star. This works for stars out to a few thousand light years, especially when we use a special astrometric satellite that has a larger orbit around us than we could otherwise see. And that gives us the distance to stars within a few thousand light years. And then we notice that they come in particular families of colors and brightness and spectral lines when we analyze them. And then we recognize those same types further out and then know how far they must be to appear the brightness they do. So that's how we know the distances.
Great.
And we know it accurately, too. Yeah.
Yeah. Aaron McConnell. Now, this is one of the, I think some of the conspiracy theorists have grabbed hold of this term tetrad. So Aaron is asking, what do you think about the biblical coincidences of the tetrad in relation to the apocalypse? Now, first of all, Bob, what's the tetrad?
I have no idea, Paul. Do you?
I believe it's the fact that 4 eclipses are occurring in this year.
Well, tetra means 5, so why would you have
maybe I got it wrong there then. Well, there, you've stumped us. Aaron, you've got us on that one. Who knows? Will the world end tomorrow? All I can tell you is that in 2012, Bob and I did a full 24-hour long show. We were observing the solar system, the sun, the moon, the planets, galaxies, because we were waiting for the mysterious Planet X, the end of the world, but it didn't come. So actually, Slooh covered the end of the world live. Didn't happen then.
It didn't happen then, but
not sure it's going to happen this year.
No, but if you say, is it going to happen tomorrow because of this eclipse? The honest answer is probably not.
We can never be certain. There's a lot of near-Earth asteroids out there with our name on. Bob, we'll go to USA Truther. Slooh, I think your questions are being filtered. Where is Planet X or Nibiru? Is that real? Now, please, I honestly didn't see that before. I just said everything I said before. Now, something that is incredibly interesting recently, USA Truther, is although it's not the Planet X, a new discovery has been made in the outer solar system, which is tending to suggest that there could be one large planet which has not yet been discovered. Bob, have you been reading up about this?
Well, the problem with this, yes, I've heard of this, but the problem with this is that the orbits, particularly the orbits of Uranus and Neptune and Pluto, even though Pluto has been demoted from full planet status, are so well known now that there's no residual error that suggests that they're being pulled by anything in any significant way. So it would have to be a smaller body. Now, of course, we know that there is Eris and Quaoar and Sedna and Pluto itself, that there are Kuiper Belt objects, but a really major body, I'd be very skeptical about it. About its existence.
Well, where this hit the news, I think, last week, Bob, was the discovery of this new dwarf planet out in the orbit, I think slightly further out than Pluto. And the people at NASA believed that its orbit, which was really quite eccentric, could suggest that there was this larger body which was yet to be undiscovered. And I think this is where science and conspiracy kind of mix, because Bob and I are quite happy to turn around now and say, well, frankly, we still don't know, because the evidence always changes. But the only thing we can do is use the evidence of today, not the conspiracy theory of today, look at the evidence of today. And what we can say is that actually the story changes as we go along. That's right, isn't it, Bob?
It does. It really does. That's how science works. But yep, exactly.
So let's move on. We have got another question from a key. You can tell I haven't been asleep 24 hours. What happens to the moon when on a solar eclipse all the radiation of the sun hits the moon?
In an eclipse of the sun, all the radiation hits the moon. Well, the moon, you mean like during this eclipse? I'm not sure I'm understanding the question.
I would read this as being, well, look, if in a solar eclipse, the moon is between us and the sun.
But it doesn't receive any more solar radiation than at any other time.
That's the answer. The moon is always orbiting Earth once every lunar month, and so it always gets that same distance from the sun.
In fact, the only time that it gets less is tonight, when it was in Earth's shadow. Here it actually got less solar radiation for a couple of hours.
Good point, Bob. Good point. Claudia, Slooh, is it possible to have a lunar eclipse when it's not a full moon? Great question.
No, it can't, because for it to be a lunar eclipse, the moon has to go into Earth's shadow. Our shadow is cast in the direction exactly opposite the sun. And so if the moon is in the direction opposite the sun, well, that's where it is when it's a full moon. So the only type of moon that can be eclipsed, that is go into Earth's shadow, is the full moon.
Okay. We've got one here from Alicia Dependifer. I'm sorry if I pronounce that totally wrong. Slooh, what date is going to be the next lunar eclipse? What date is going to be the next
October 8th.
Solar eclipse?
Well, October 8th will be the next total lunar eclipse, and we're going to have that visible from the United States, especially the western United States. As for the next total solar eclipse, we're going to have that on March 20th of 2015. Next year, March 20th. Unfortunately, the path of totality, after passing south of Iceland and then going over the Faroe Islands of Scotland and then heading north, we'll stop at the North Pole. The sad thing about this is that the North Atlantic, at that time of year, that is on the very first day of spring, is almost always solidly and deeply overcast. So we eclipse lovers and chasers are not very optimistic about that one.
Absolutely not. Now, we have got two last questions. You can see we are still watching. The eclipse is still going. We're seeing just this last little bite of the moon being taken out. So we're still watching those lovely live images from the Prescoll Observatory. We've got a couple more questions here, Bob. This is a nice one, and especially because we were talking about Mars tonight and thinking of its moons. Abdul Rahim asks, Slooh, does gravity naturally create spherical shapes?
It does if there's enough mass in the object. If an object has enough self-gravity, then when it's forming, especially if it starts off as softer, as a molten body, it will pull itself just by its own self-gravity into a spherical shape. Now, even Ceres, which is far less massive than the moon, that is the most massive of the asteroids, had enough gravity to do that. Pluto had enough to do that. But as soon as you get to less than that, you just don't have enough oomph. And then you have celestial bodies such as asteroids and many of the minor moons of the solar system that are irregular in shape. So simply put, you've got to have a minimum amount of weight or mass, and then you'll be round.
Okay, we've got one last question, Bob. This is not going to end on a high note for you because I know this might annoy you. How did the astronauts survive the radiation belt if they actually went to the moon? It's a serious question that people want to know the answer to.
Well, the radiation was significant. The astronauts all wore dosimeters that measured the amount of radiation, and it wasn't nothing. In fact, one of the astronauts later died of cancer that he said in an interview might have come from his Apollo missions. So there was some radiation, but it certainly wasn't a lethal amount of radiation. It was well known, well measured, and that's why we can send and continue to send astronauts into space, because even though it's worrisome, it's not lethal. And so far as anybody who doubts the astronauts being on the moon, I'd have a simple answer for that. And in addition to the 500,000 people who worked on the Saturn V rocket and the Apollo program and actually spent 10 years working on the components, I mean, what were they doing all that time? Doing nothing? But the big question is this. A rocket went up. I watched one of the launches. We saw it go up into the air, carrying supposedly the astronauts, and it disappeared from view. Where did it go if it didn't go to the moon? If it only stayed in Earth orbit, we had enemies like the Russians back then and the Chinese who had radar and tracking capabilities and would have been very happy to yell to the world that we were only in Earth orbit, that we weren't going any further. Plus, an object in Earth orbit can be seen, can be tracked, can actually be visibly tracked. We saw the spacecraft go up. We saw the rocket go up. We saw it disappear into the distance on a lunar trajectory, and our enemies never screamed, hey, it didn't really happen. Plus, we left behind things on the moon like corner cubes that send back laser pulsars to any
they're still being used,
college.
I think, Bob, aren't they?
They're still being used, and it tells us that the moon is spiraling away from us, and any college or any research institution can shoot laser pulses to the moon, and sure enough, well, about 2 seconds later, they'll get the return flash. And so how did they get there? So it's silly talk. It's so, these questions are not answerable if we didn't go to the moon.
Yeah, I quite agree. Now, there are lots of other lunar phenomena that we've been covering, actually, at Slooh only last year. Last year, Bob, I don't know if you recall, but we did 2 shows where something that had previously been, I don't think, denied by NASA, but I think there was a certain resistance for a number of years to believe the reports that they were receiving from amateur visual astronomers of seeing flashes.
Flashes on the moon, yeah.
Flashes on the moon. Now, last year, there happened to be 2 examples which were actually captured with video. And NASA actually have their own permanent observatory now watching the moon, and it's looking for these impacts, because one of the big topics we've been pushing hard at Slooh is the campaign to really raise the profile of the threat from near-Earth asteroids. And what those things were witnessing was asteroids or small bodies actually impacting the moon, and they were caught on video camera last year. So those are the kind of events that we cover here at Slooh. So we don't just do the big eclipses, we do just about anything that's newsworthy that can be seen through a telescope. We're here to show it to you live. Bob, we're rounding up the show now. There's a few more minutes left of the eclipse timing. I think it's 4 minutes, isn't it, on my sheet?
Yeah. That's right. And you could see that the shadow has retreated. There's almost nothing left on the moon. There will be a little slight darkening on the side of the retreating shadow, simply because that's the area that's not fully blocked by the Earth. In other words, the sunlight isn't totally absent, but it's 99 or 98 or 90% or 80%, depending upon the exact spot of the moon, blocked. So the partial phase will end in just a couple of minutes, but there will be a decreasing amount of duskiness on the right side of the moon for the next hour or so, but the real eclipse will be over. It's just wrapping up now.
So while we wait for that countdown, I would just like to go back and thank everybody who's been involved with our shows tonight. Don't forget, it wasn't just the lunar eclipse that we were covering tonight. We also covered the Mars closest approach to Earth in 6 years. And our guest there was Robert Manning. Robert's been on our shows before. He works at the Jet Propulsion Laboratory at NASA, and he's got one of the coolest job titles in the world. He is the Low Density Supersonic Decelerator Project Chief Engineer. Isn't that cool, Bob?
It's very cool, and he was a great speaker. He was really great to have, a good, level-headed, inspirational speaker for us.
Gave us some marvelous explanations of the mechanics and the engineering behind trying to slow down the landing one of these rovers onto the surface of Mars. Now, if you miss that, sure, you miss any Slooh show, you can always catch the recorded versions. We put those on the slooh.com homepage. Don't forget, you can still join up today and get those free binoculars. So don't forget about the promotion. But for the total lunar eclipse, the first thanks has to go to Matt Francis, director of the Prescoll Observatory in Arizona. Matt's been providing us these wonderful images from his personal observatory in Arizona. Bob was actually there alongside Matt to broadcast with us tonight. And we mustn't forget those people who did all the work to set up a feed for us tonight, but who were clouded out. Bob, your daughter in New York is one of them. So, you know, huge thanks to her. Angeli Berman for Woodstock, is that right, Bob?
Yes, just outside of Woodstock, in the middle of nowhere, where there's lots of bears, but not much else there. Yes.
Angeli did so much preparation work and testing for us. You know, it's such a great shame when the clouds spoil the view, but that is astronomy, I'm afraid. You know, it's the one thing you shouldn't get frustrated about. We also had on our show tonight, well, the first guest we had was Professor Timothy Ferris. He's written the Hayden Planetarium show, actually, Dark Universe, which is pretty cool. And he's got a new documentary coming out on National Geographic that you should keep an eye open for. We had Michael Narlock. Wasn't that great to introduce Michael tonight? He's Slooh's new educator, the Slooh educator for our new program, Slooh Classroom. And that's an initiative that we are all really looking forward to. Once again, if you missed the details of that, have a look at this show again for that segment. And Michael explains everything. He even gave us the second classroom. I thought it was the first classroom, but actually you'd already done one during the week. So Michael's second classroom. So if you've got kids in K-12, that kind of syllabus, Michael's going to be putting together a huge amount of content and shows and material so that kids can use the Slooh telescopes and look at the live views and use that in their curriculum studies. So that was Michael Narlock. He joined us from California, and he's going to be hosting some of our shows and doing some of the production. And last but by no means least, and I really mean, oh, by the way, we had Duncan Copp, documentary filmmaker. He was on our live recorded segment with Bob Berman. Bob is a professional astronomer. He's an astronomy author. You've probably read his articles in Astronomy Magazine or maybe some of his books. Looking up on Amazon, they're always a fantastic read. Bob, huge thanks to you. You're always that wonderful mine of information. We couldn't do these shows without you.
Thank you, very kind, Paul. And yourself, of course, the same is more than true for yourself. And
well, thank you very much for that. There's also the unsung heroes behind the scenes. We've got Michael Wilson. He's in Connecticut. He's been our producer tonight. That's a huge amount of work to do for a 4-hour show, especially when it's after a 1-hour show. But, you know, I'm going to leave the last and biggest thanks to Slooh members, because without Slooh members paying to use Slooh's robotic telescopes, we wouldn't be able to put on these live free shows. So even if you don't want to use the telescope, join Slooh anyway, because it enables us to do this. And don't forget, we've got that fabulous promotion on. I'll tell you, those binoculars are really cool. They're not a cheap pair of binoculars by any means. They're big and multi-coated optics, all manner of stuff. So really, really nice pair of binoculars that you'll get free. Just go to slooh.com, press the membership button, and you'll see all of the details of that offer. Now, that is limited time, so you've got to get there quickly. Thank you to all of our viewers tonight. We know that we've had questions in from people around the globe tonight, and it has been a long event. A lunar eclipse is possibly one of the longest events like this that can be covered, isn't it, Bob?
Yes, it is.
Yeah.
I think we're all tired. And you, Paul, my goodness, what time is it where you are?
It's 20 to 11 here in the morning. So,
20 to 11 in the morning, and Paul
27.
has not slept in more than 24 hours. So,
absolutely.
I've
I've probably gone past it now, Bob. I've probably gone past it now. So, listen, thank you very much, Bob. Thank you to all of our guests tonight. Thank you to everybody behind the scenes at Slooh. Thank you to all of our Slooh members. And thank you to our viewers. If you've made it this long, you're made of stern stuff as we look at this last image of the lunar eclipse from the Prescoll Observatory in Arizona. I'm Paul Cox. I've been joined by Bob Berman, and our other guest tonight, Matt Francis of the Prescoll Observatory, has been providing our live images. I'm Paul Cox. This is Slooh Community Observatory, and we'll see you on our next live event. Good night, good morning, or whatever it is, wherever you are. Goodbye, everybody.
Good night.